in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
Whoa!
Happy Sunday. I kind of just woke up like an hour ago, actually. This jet lag, I'm telling you, I don't know what's going on.
Oh, no.
Surprise, motherfucker.
Super annoying. I mean, it probably also didn't help. I was out at some parties till 6 a.m., 7 a.m., so. But we're here. An hour earlier than we usually stream. I have another birthday event I have to go to tonight down in Santa Ana, which I think is going to be about an hour and a half drive. So I'm not looking forward to that.
No.
Also with gas prices being what they are, I'm starting to like do calculations of how expensive it is to go say happy birthday to this person. But they're cool. They're a cool friend of mine. So gotta go say hi. Like me, a bunch of other people there. So we're here streaming an hour earlier. Let me start the stage on Discord. Office hours. There we go. As always, we do update the calendar pretty regularly. So if you're ever wondering like when we're streaming and like, you know, maybe it's not showing like the right time or something, you can always go to actualofficehours.com. Click streaming schedule. It should be on there. There we go. Yeah, nice. That's the updated streaming time. Awesome. Let's see. We had a fun time playing chess yesterday. That was a lot of
Good job.
a lot of fun. I played against Rex and stuff. What's up, Dennis? What do you want to say? Rascal's here too. Nice. Good to see you too, Rascals. And then yeah, today we're gonna do some homework help. Trying to think. I'll have you guys vote on which video game you guys want to play on next Friday. And then I'm going to talk to maybe Narosky and Ramton and see if we're going to have some special streams at the end of the week. So yeah. Another week in paradise.
Let's see. What's up, Poison Mouse? Good to see you. Good to see you. Alright, other than that, Brassicle's already got a question for me. Is this already gonna be something like super crazy fun? Also, Brassicle's, test out, can you join the stage yourself? Do I have to give you permission? Really? Man, I made you a stage monitor. Oh no,
There you go.
No, yeah. I pressed the request to join. I didn't realize that there were. Like,
Yeah, you can
two
just
different
join.
buttons.
Yeah, okay, cool, nice.
Yeah.
That works. Okay,
No,
dope.
I think this one's kind of cool. I like
This one's
one.
cool. Okay, we like cool.
It's an interesting way to solve it.
Okay.
And I get to teach you a bit of PDE.
Ooh, yeah, I haven't really taken much with PDEs at all. I'm happy about it. Yeah.
Yeah, there's a little bit of PDE in there.
Poison says baby voice should be doubled. What would you double about baby voice? How would we double it? Like make it twice as high pitched? I think it's already pretty high pitched. My voice is already pretty high pitched. What's up, Jamarcus? Good to see you too. How's life? Epstein zeta function. I have no clue what an Epstein zeta function is.
I don't know, but I found it on Wolfram.
Is that something to do with like an island and children?
Oh no.
I hope not. I hope not.
The Epstein zeta function. I don't think we can really say that name, can we?
I don't know.
Why is my Twitch chat not showing in my thing or whatever? Okay, we'll figure it out. Okay, that being said, let's start off the stream, help you guys out with some math and science homework, and here we go. Alright, welcome everyone to Actual Education Office Hours. My name's Dr. Gold. This is a live stream that helps you out math homework, science homework. All sorts of fun stuff. Let's go live on TikTok. Let's go live on Twitch. Let's see who can help out. Yeah, we're ready. Let's go live. Dun, dun, dun. Bum, 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 bum. All right. I hope he didn't find gold drilling. Uh-oh. Okay, here we go. Let's go see on the website what questions we have in the queue already. Wow, breasticles. There you go. And Gladiator Leos. About a 50-50 shot right now. Looking like a 50-50 shot. Let's see what's going to happen here. Choose a winner. Spin, spin, spin. Who's going to win?
Let's go gambling!
Oh, it's Gladiator. That was very close, though. Yeah, what was it? 46 to 53? Basically 50-50. Okay, Gladiator. Let's see what we got with you. Ooh, yo, what? Oh, this is fun. This is going to be an optimization question. Right? I feel like we're going to do optimization. This is calculus. Calculus. Or maybe not even calculus, because sometimes these things are quadratics and you just need to find the vertex, right? It's like two different ways to do it. Okay. Describe the area of the largest rectangle that can be inscribed inside a semicircle with a radius of 10 units. Place the length of the rectangle along the diameter. Cool. Let X represent half the length of the base. Let Y represent the height of the triangle. They really like held your hands on this one, because I would have struggled a little bit actually to define like what my variables are and where they are, but they kind of just already told you. So let's see. I forget, Gladiator, are you in calculus or are you in pre-calc? Like, do you know what a derivative is, or do you just know what like quadratics and vertices are? I'm curious like which way you want us to solve this. There are a couple different ways we can do it. Calculus. Okay, cool. We'll do calculus then. Calculus is great. Okay. So this is called optimization. So always what you want to do is figure out what you're trying to optimize. So in this case, I'm trying to optimize the largest area. Okay. Yeah, I'll show. You can also do it with pre-calc. I'll show you. It's very easy as well. But here, so largest rectangle means I need an area. Okay. So area is what I'm trying to optimize. And then let's come up with like an equation for what the area would be. Usually this is where things get tricky, because you have to start defining like variables and things. They already gave them to you. They already told you what the variables are. They said, let's let this represent the half length of the base, which is X. Let's represent this as the height. You know that the area of a rectangle is equal to the base times height. And so the base in this case would be 2x. And then the height in this case would be y. Right? So there. So you get like 2xy. Cool. Dope.
Yeah.
Now, here's the issue. We're trying to optimize this area, but I have something in terms of two different variables, which is a problem.
Oh no.
You can't optimize something with two variables. Well, you can, but for all intents and purposes, here, in intro calculus, no. So what we want to do is try to rewrite this in terms of one variable, which means we usually need to take either the x or the y and write it in terms of the other thing. And the cool thing I know is that if this is inside a semicircle, okay, then technically this diagonal here is the radius, and that radius will always be 10. And so here we can draw some other rectangles so you can kind of see what's happening here. Let's say, for instance, you had this was your rectangle, okay, and in this case this would be like the quote-unquote diagonal here, where this is now a distance x and this is a distance y. This distance from the center of the middle of the rectangle, which is also the center of the circle, to the outside of the circle, or like the outer corner of the rectangle, that's always 10. So we can also see this will always make a right triangle, right? Because the width of the rectangle and the height of the rectangle will always be 90 degrees to each other. So in this case, what I notice is, oh, hey, this, and this make a right triangle. This will always be 10. So I can say that x squared plus y squared always has to equal 10 squared. Yes, the reason why they made x half the base is for this right triangle. If you made this whole thing x, then in doing this step, which is relating the variables, I would have to say, let's say, for instance, this was x. Then I would have to say x over 2 squared plus y squared is equal to 10 squared, right? Because then this would be x over 2. So instead of baking that in to the Pythagorean, they bake it into the area. The x over 2 versus 2x. What is this? Using the limit definition of a derivative, find f prime of a if is equal to... Is that awful? I don't know if that's awful. I mean, it's messy algebra for sure, Jamarcus. What's this, Bella? This is the circle formula, by the way, Gladiator. This is the circle formula, right? This point right here is x comma y, right? And for a circle of radius 10, right? Or just, let's say radius r, right? The equation of a circle is x squared plus y squared equals r squared. It's the same thing as this also comes from, right? Do you see how this also comes from the Pythagorean theorem? You're saying, you know, as I vary the, what is it? The width and the height of a triangle, the diagonal always has to be 10. And that's like a radius. Yeah, it's the same thing. Yeah, they're all related. They're all pretty cool. So, what's up, Famished? It's going great. Okay, so here's the cool thing. So now I have x squared plus y squared is equal to 10. I can use that to substitute in for here, so that now my area equation only has one variable. And it doesn't matter which one you do. For instance, let's use x squared. I can do chem, yeah. Yeah, any chem, math. Yeah, so here, anyone who's watching, if you want to submit a question, Valentine, for us to go over, the website, actualofficehours.com. Go to this website. It's linked down below there. And then put your username in, drop an image, hit upload, and then that'll get added to the queue here. And then what we do is every time we finish a question, there's like a little random spinning thing that determines which question we do. So the sooner you get your question in, the better chance you have of getting picked. Also, if you click this upvote button every 3 minutes, you can like increase your chances. Isma says, in Morocco, we do complex analysis senior year. Wow, that's pretty cool. I did complex in college. Pretty advanced for you guys. Okay, so I'm going to rewrite this as x squared is equal to 10 squared minus y squared. And now the cool thing is, that tells me x is equal to the square root of 100 minus y squared. Okay? Technically, it's plus or minus, but we're only going to consider positive values of x. It doesn't really make sense for the thing to have, like, negative width. Right? So. Yes. Yes, Bella, right. Yeah, okay, so cool. So now you're going to plug this into here. Okay? So actually, this isn't solvable. I was hoping this might be solvable by just a basic quadratic, but it's not. Okay, so this is going to be 2y, and then square root of 100 minus y squared, and that's equal to a. If this was something nice, let's say, for instance, this was like, I don't know, like y squared plus 2y, I don't know, like minus 6, then technically this would look, you know, something like this, and you could find the vertex, and then that's like the minimum. If you were trying to minimize something, and then, you know, if it was the other way, and it was like this, then you would find the vertex, and that would be the maximum. That's the special case in situations where you're trying to maximize or minimize something that behaves strictly as a quadratic. You can just look at the vertex. Yeah, set two equations, sub in, and then in terms of one variable, then differentiate. Yeah, exactly. So now you're here, right? So I want to minimize this, and what you learn in calculus, right, is that minimums and maximums occur for this when the derivative of this is equal to 0, because that's what a critical point is. So what we're going to do here is we're now going to do dA dy. So we're going to derive this with respect to y. That's what this dA dy means, right? You're doing the d dy. The reason it's dy is because that's the variable we care about. And then this is kind of a messy derivative. Okay. I'm going to notice that this is, well, let's see. I could multiply in and chain rule, or I could product rule. I'm going to product rule.
Chain rule would probably be easier because you're gonna have to use the chain rule. Because you're gonna have to use chain rule anyway for the y squared.
You're right. You're so right.
So
yeah.
you're gonna bring a bigger coefficient instead of having to do a product.
Breasticles is right. So yeah, instead of doing like the product rule between these two things, I can rewrite this as the square root of 4y squared times the square root of 100 minus y squared, and then I can bring this in because square roots times square roots can be under the same house. So this ends up being the square root of 400 y squared minus 4y to the 4th. What's up, Storm Gaming? We're doing like an optimization question right now is what we're doing. Thanks for the follows, guys. Is the method of proofs of math super hard? I'm low-key scared for the class. No. I mean, it's definitely... I struggle with like proof by induction. And the only way to get better at that, honestly, is just to like do a bunch of examples. But otherwise, I think proofs are really cool. They can be difficult to wrap your head around sometimes, but I don't think they're necessarily hard. I think if you study how other proofs are done, it can be pretty easy to pick up on the patterns. Okay, so we're gonna have this like so, because now what I can do is I could rewrite this even more so. I can say, oh, this is the same thing as this. All to the 1/2, right? And now we're gonna do dA dt, and then this will just be is area 2x times 2y? No. So x is this half distance, Jeff. So it's 2x times y. Yeah, it's a half rectangle. Getting a lot of follows today. Thanks for all the follows, guys. Appreciate it. Okay, so now let's do derivative. Let's do some derivatives. So we're gonna do dA dy. Which, okay, so this is where you have to remember kind of like the chain rule. So I don't know what the derivative of all this shit to the 1/2 is, but I do know what the derivative of something to the 1/2 is, right? It's just gonna be 1/2 of whatever that something is to the negative 1/2, right? Right? Pull it down, drop the power by 1. And then we have to do the derivative of like whatever was inside, right? So, I'm gonna move this. So this comes away. And then we're gonna do ddy of this, which the derivative of that is, what is that? 800y minus 16y to the 3rd. It's kind of messy, actually. I don't like this. Okay, cool. So now we get, all right, dA dy is equal to, this is gonna be on the top. So we're going to say 800y minus 16y cubed. There's a 1/2 in front of everything. And then because this is negative 1/2, we're going to put that on the bottom. And that's going to be 400y squared minus 4y to the 4th, all to the 1/2. Or you can put a square root here if you want. It's kind of cool. You want to ask a question? Storm Gaming. Yeah, if you have a math or science question, you got a screenshot of it. All you have to do is go to the submit page. It's right there. And then that'll show you how to like upload a question for us to go over. Okay, cool. All right, this is the derivative, and I want this to be equal to 0. Okay? Because that's where I know where there's either a max or a min or something. I'm pretty sure it's going to be a max. The other thing you're technically supposed to check when you do these are like the endpoints. Like what's the maximum and minimum value that could happen for like x and y. And I think what you notice here is, right, you could have x go all the way out to 10, right? But if you did that, y would then go to 0, and that would be an area of 0. So that's very obviously a minimum, right? Yeah, it's kind of that's what we say. Like, that's a trivial answer. Yeah, the minimum area is 0. It's not even a rectangle at that point. So anything else has to be a maximum. We could technically take the second derivative and look at it, but I'm not going to go that far. I don't think we can just assume this is the maximum. Okay, so in order for this to be 0, I'm just going to completely ignore anything on the bottom here. Because as long as I'm not dividing by 0, we're fine. I really only care about this going to 0. And honestly, I don't even care about the 1/2, right? I just need this to be 0. So I can say, okay, how can I get 800y minus 16y cubed equal to 0? Well, I can factor out a y at least, right? Let's do that. So I have y, 800 minus 16y squared is equal to 0. And then again, you see that there's 2 solutions here. Actually, it's probably 3 technically. We could have y equal to 0, but that's nonsense. We don't care about y being 0. That doesn't give me a rectangle. So again, this is what I care about equaling 0. So I can say, okay, 800 minus 16 y squared is equal to 0. All right, how does that happen? Let's move it over. My favorite part is the knowledge that y necessarily is equal to x. Is it going to be a square? Probably will be. Let's see. Probably would end up being a square. I think y is going to equal to 2x is what's going to happen. We'll see. Okay, so then you divide this over. Y squared is equal to, oh man, what is that 50? I think so. Yeah, 5.
Yeah, it's 50.
It's 50? Okay, cool.
My man.
All right, so then y is equal to plus or minus the square root of 50. Again, it doesn't make any sense to have negative y's, so we're just going to leave the positive one, okay? And there you go. Okay, so we know y is equal to the square root of 50. Cool. But then let's remember from before, right? X squared plus y squared has to equal 100. So that's how, here's how we can figure out what x is. This is actually this is gonna be really cool. Come down. There we go. So let's plug that in, and I'm gonna get the x squared plus the square root of 50 squared is just 50 equals 100. Now subtract 50. X squared equals 50. Oh, x is equal to the square root of 50. Oh, x is equal to y. Oh, that's cool, actually. Okay, cool. So there you go. You have x is equal to the square root of 50, y is equal to the square root of 50, and then that means the maximum area. So area, which equals 2 square root of 50, square root of 50, is going to equal to 100. Right, square root of 50 on square root of 50 is 50, times 2 is 100. Yes. I see, considering the single chord of a circle, I get you, Thomas. Yeah, you're saying that, like, if I were to look at this in like, just this quadrant, the maximum area you can span from, here, let me do that. If you were to just look at this quadrant, and then I can make a cool little thing. Yeah. Here, if we were to, like, consider all the different shapes, the one that maximizes area is where it's literally a square. So cool. Yes, X has to be between 0 and 10. Storm Gaming. I did. Yep, Storm, you're on the queue. You're right there, Storm. See? Cool. All right, there you go. Yep, so X equals square root of 50, Y equals square root of 50, area equals 100, and you're done. Nice, good question. Sick. Okay, cool. Dun, 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 dun. All right. Good question from Gladiator. So yeah, the basic strat in those types of questions is first come up with an equation for what you're trying to optimize. It'll be in terms of a bunch of variables, and then you need to come up with a second equation that relates one of the variables to the other one. That's how optimization works. Kind of the same with like related rates and stuff too. They kind of do the same thing too. Simple high school stuff, cool. Well, we'll see if we get to it. I might be doing a hard question. Breasticles maybe has something really fun with partial differential equations. So if he gets selected, don't be too scared.
Oh no.
For learning purposes.
It's really not. It's not that bad for a
It's-
PDE, and
Okay.
you can technically solve it without it. But I think the PDE solution is cooler.
Oh. Wait, why did my bot not work? What the fuck? Bot. There we go. Bot worked now. Okay, cool. All right, here we go. Yeah, all right, there we go. So this is the queue of questions. Again, oh, you guys are smart. You're all hitting the upvote button. Yeah, every 3 minutes you can hit upvote if you want to like increase the chances of you getting selected. So let's go choose a winner. See who's gonna win.
Let's go gambling!
Wow, dude, SJ only had 6% chance.
That's dope.
Wow. Breasticles, dude. The spinner wheel of fate is delaying. It's delaying the pain.
It's rigged.
It's
It's
rigged. All right. Although this is interesting. Someone's asking me something about TCP, dude. What?
Aw, dang it.
Who's asking me this? Who's asking me a TCP question? Feeling good to listen? Hell yeah, dude. Nice. Yeah. I say this is better than, you know, the other, like, brain rot or, like, thirst trap shit you see on, like, YouTube shorts and stuff, so. Enjoy. You'll probably pick stuff up, honestly. If you listen to it for enough time, like, you'll learn things. Even if it's, like, way above you. All right, let me see. I don't think this is a very interesting question about, like, networking. Not exactly, like, math, but maybe. All right, 10 MIPS link, which is not buffering data, supposes that this link is the only congested link between the sending, assuming the TCP has a huge file to send and the receiver's buffer is much larger than the congestion window. We also make the following assumption. Each TCP segment is 1500 bytes. The two-way propagation is 150 milliseconds, and this TCP connection is always an avoidance phase. This is so far out there. In terms of like just technical jargon, I've never dealt with this, but maybe we'll learn something today. What's the maximum window size and segments that this TCP connection? I'm not gonna give up. I'm just gonna send it to ChatGPT and we're gonna learn. Because that's what happens, you know. Like sometimes you get questions you have no clue how to do. Which I appreciate people sending me new stuff that I've never seen before. But you can use AI to learn, for sure. How long would it take? Blah, blah, blah. Okay, bunch of cool things. Yeah. +1 Valoo. Yeah. Maybe let me define some things here. Because also, I mean, you guys have probably seen this, for instance, in like speed tests and things. You'll see like this. This is megabits per second, right? Interesting thing about this doesn't represent megabytes per second, which I think is MBS. Is it? I think this is technically what megabytes per second is. There are 8 bits to a byte, right? I think that's how it works.
Yeah, 8
Right.
per byte.
Good, exactly. Okay, so technically, this converts down to 10 divided by 8, which is 1.25 megabytes per second. So even though, I mean, some people talk about, oh, I have like a gigabit connection, like, oh wow, it's 1,000 MIPS. That's what we say, like megabits per second. You're effectively only able to download at 125 megabytes per second in this case. So just because you see this 1,000 number doesn't mean you can download a gig every second. You can download a gig every 8 seconds. Or MB Hertz. Oh, really? I've never seen an MB Hertz. That's cool. TCP, I think, is like an internet relay, or it's like a networking protocol is what it is, and it's for like sending stuff over. You just made that up. Okay, Jeff. There's also a curious thing. I don't know if you guys have ever noticed with hard drives and stuff. Have you ever noticed that like you get a 100 gig hard drive or even like a flash drive, right? You get like a, what is it? Like yeah, I don't know that. Like a 128 gigabyte hard drive, and it doesn't actually store 128 gigabytes. That's like a marketing thing. So, for instance, they will say that 1 gigabyte is equal to 1,000 megabytes in terms of marketing. But in terms of how computers work with binary bits, everything has to be like on and off, which is like pairs, like twos. Technically, the computer sees 1 gigabyte as 1024 megabytes. So what they sell you is this. This is what they sell you. They sell you this, but this is what the computer uses. So in effect, even though you could say like, oh, I have a 50 gig hard drive, you can't store 50,000 megabytes of stuff on it. The usable space actually becomes less, and it's because of this little fact here, which is kind of crazy. All right, I'm just gonna throw this into. You want me to use Claude? Yeah, we can use Claude on this. You think Claude's better? I think ChatGPT is better for like coding and stuff. But let's try out Claude on this one. I'm down. I don't think we need. Do we need Opus 4.6? We think. All right, whatever. Let's just send it. Use my usage. Dun, 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 dun. Oh, cool. Yeah, look, they converted bytes to bits. See, this is, yeah, these are all, this is very much how engineering works. They have all these cute little definitions for things that, unless you're in the class or like, you know the words, you won't be able to solve this. Which I think is kind of like, I don't know, I don't like it as much. This is why I prefer things like physics and math, because you don't really need to know as much specialized jargon, because everything can kind of be derived from like prior things. This, like, the only way you could solve this is if you took the class and you knew, for instance, like what maximum window size is. What, like, you know, what? It's just, that's an equation. Okay, so apparently maximum window size is when the sender is transmitting at full link rate. At that point, window size times segment size divided by RTT. RTT is the delay. This is also ping. You Fortnite players, have you ever noticed you're like always asking about your ping? Like, oh, I have high ping. That's why I'm like, you know, losing all my 1v1s. You know, yeah. This is ping. This is like the delay between data being sent and received. And again, I have no fucking clue what congestion avoidance is, but all right. So they say W times segment size divided by RTT equals link capacity. And so I guess you're solving for W at this point, which is window size. So that's equal to link capacity times RTT divided by segment size. Segment size, they said, was 1,500 bytes. So I guess you have to convert that into bits. Oh, you want everything to be in bits. I see. So, yeah, okay. That's the 12,000. Segment size was that, and then RTT was, yeah, that's the delay. That's milliseconds, which you can then write out. You want to do this in seconds because this is megabits per second. So you want the delay here to also be in seconds. So that's 0.150 seconds. I mean, there are some useful things here that parallel other stuff you do in math and science, like making sure all the units are the same. So this would have to be 0.150 seconds, and then this would have to be 10,000 bits per second, right? Which is the same thing as, or no, not 10,000. Sorry, I take that wrong. Sorry, mega means million. Sorry. So it's 10 million bits per second. Yeah, sorry. Megabits. There's 1,000 kilobits in 1 megabit. That's how that works. Yeah. You gotta know your whatever the Greek things, the prefixes. Okay. Right, and then this is the same thing as 10 times 10 to the 6. So that's all they do. They calculate it. Cool. 125 segments. I don't know what segments are. In TCP congestion avoidance with the classic sawtooth behavior, the window grows from W/2 to W when a loss occurs and is halved back to W2. The average window is 3/4 of that. Okay. I know what a sawtooth is, right? This is actually a cool thing that happens in like signal design. So this is like a saw wave. I guess what they're saying is the window is, the average window here is 3/4. I don't know where that comes from, but if it was, again, you can go back to this equation. W times segment size of RTT's link capacity. And then, nice. Yeah, cool. 75% of 10 MIPS is 7.5. Time to reach maximum window after recovering from a loss. Oh, this is cool. AX. Okay, this is another kind of networking thing. Have you ever heard of like SYNAC? This is, and this is also how, for instance, DDoS attacks work. Have you guys ever heard of like websites getting hacked? Which is called a distributed denial of service.
Yeah, we used to do that all the time on R6 when we on Xbox.
Yeah.
Back like a couple of years ago. Once you started losing, pull the IP and hit it.
Just start smashing
Yeah, so it either just like shuts down the server, or whoever's like carrying the team, you just knock them right off the team for the next 15-20 minutes.
So it's actually, I can go a little bit into like how a DDoS attack works. I think this is something that's maybe like lost on the new generation. They're just like, oh, I got hacked, and like, but you didn't grow up in the age of like not really knowing what hacking was. But yeah, DDoS, yeah. So what happens is whenever, just in simple terms, if you have like let's say a client here, and then this is going to be a server, what usually happens is the client will send a packet or a ping to the server, and I believe this is a SYN command is what it is, and then the server will respond with an acknowledge. That's why it's called SYNAC. So I think the client goes to the server. It's like, I think SYN stands for sync, maybe. It's like, hey, sync, like, hey, I'm sending you a packet. The server sends back an ACK, and then it waits for the next, it waits for the information to be sent from the client to the server. I think this is the client like knocking on the server's door, being like, hey, I'm going to send you something. And the server's like, cool, yeah, here you go, man. Yeah, I'm ready to receive it. But then the server never receives the package. So the server's just like waiting here, and it's just like, you know, when is it gonna show up? Which is okay if one client does this to a server. Where the first D in distributed denial of service attack happens is, instead of having one client like knocking on the door saying, hey, I'm gonna give you a package, you have like 1,000 or like 1,000,000 or of these happening. So you have a bunch of people knocking on a server's door, asking for acknowledgement because I'm gonna like send you something, and then never sending it. And then the server gets overwhelmed because it's sending all these ACK commands back, and it's never receiving any packages. And so what happens is the server then doesn't know how to handle legitimate requests, like legitimate SYN requests coming into it, and it just shuts down. Yeah. So. Yeah, it's like doorbell. Yeah, it's like ding dong ditch. Yeah, doorbell. What do we call it? Ding dong ditch? Is that what you called it? Ding dong ditch? Yeah. Don't do that these days.
Oh no.
You see people getting like shot in America for ding dong ditching. Don't do it. Don't knock on random people's doors. What's up, Alistair? So, anyways, yeah, that's where this after packet loss. Yeah, I love this. I saw Axe. I was like, ooh, Synac. Yeah, this is cool. Yeah, you already teach probability. Submit a probability question. Okay. Anyways, there's some math involved. That's how many seconds. Cool. I hope you at least maybe found this useful, kind of like little side quest topics. Computer's really cool. But yeah, cool question there. Polars are a pain in the ass. I do it all the time. It's so fun. Yeah. So again, the only way that a DDoS doesn't really work from one client. It has to be distributed amongst a bunch of other clients. So whenever they get like websites that get taken down by DDoS, it's not one person. It's usually a hacker that has control of thousands of computers, like thousands of home computers in random places, and it has all of them coordinate a coordinated attack to just like mob a server. There used to be a so these have to be organized usually on you know, things like 4chan or like Reddit, or Discord, I guess, maybe, to coordinate like a bunch of people to like overload a server. Fake bots. Yeah, a botnet. There we go. Exactly.
Yeah,
Like
that's what, when we were doing it on Xbox, what they had is they had just like a bunch of devices, and most people didn't even realize
that were
their
being
shit was
compromised.
infected.
Yep.
Yeah, but so then it would just be random devices across, you know, the whole United States that were, or even across the world that were compromised with this virus. But it wasn't like they were using the virus to like destroy their computer or whatever. They were running a website where you could go pay $10 and get a month of DDoSing. And then it would take all of those computers and it would just use their home Wi-Fi to send packets.
Yeah. There's a big worry about this, especially with all these smart devices and everything. It's called the Internet of Things. You heard of IoT before?
A couple of times, but I haven't looked into it too much.
So yeah, Internet of Things. You know, even in my house, I have like, you know, my light switches are smart switches. I have things connected to whatever, but people have so much shit that's now on the internet that this actually provides an opportunity for people to build botnets out of, like, let's say for instance your vacuum cleaner, because if it's connected to the internet, then it has the possibility to, you know, send commands and do stuff. Yeah. It's crazy. The one we used to use when we were doing denial of service was low orbital ion cannon, low IC. Yeah, this was it. This is so old school, dude. Remember this one? When harpoons, airstrikes, and nukes fail, there was this. Yeah, you would type in the URL or the IP, you would click the charging my laser, and then it would just go. And if you had enough people do this, it would eventually take down a website. Nowadays, you have things like Cloudflare and other like in-between services that prevent DDoSs from really like happening. But okay, let's do some more questions. Let's see. We got 5 people here, looking like some good chances. Let's go choose a winner. See who we're gonna get.
Let's go gambling!
Oh wow, it's Jamarcus. Breasticles, if you're last, dude, I'm gonna crack up, dude.
I'm being scammed here.
All right, let's try to do this. This is gonna be kind of fun, I think, or maybe not fun. I might regret this.
Oh dang it!
Okay. All right. Using the limit definition of a derivative, find f prime of a if f of x is equal to this scary thing. Cool. Which limit definition do you want to use? There's one where like what is it? A approaches h, and then there's one when h approaches 0. I tend to like the h approaches 0 one. But I know in certain cases it's easier to use the other one. H to 0. Okay, yeah, we'll do that. Yeah. Okay. Yeah. All Right. So limit definition of a derivative says f prime of a is equal to the limit as h approaches 0 of f of x plus, sorry, let me remember this, f of a plus h minus f of a all over h. BRST is kind of like, what's BRST? Is that another DDoS tool?
Oh, that's my, what I
Oh,
submitted
Breasticles.
under. Type my whole name, I think.
Oh, okay.
Unless there's just a
Breasticles.
BSRP.
Okay, yeah. I'm amazed your name hasn't got me like in trouble with like TikTok or something yet. I just keep saying
Yeah, I am
Breasticles.
too.
Yeah, it's kind of nice. Okay. This is actually really cool. Why this works? This is basically taking the limit as, this is basically the equation of the slope of a line. If anyone's ever like wondered what this is. Actually, I have a really cool graphic on this. One sec. It's on YouTube. If you go to our YouTube, go to like search here and say like limit derivative. I have a video on this. Here we go. Limit definition of a derivative. It's a cool little short I made that shows like how it works. So, this is where's the equation that they show? Where is it? Okay, yeah, cool. This is the equation they show, right? F of x plus h minus f of x over h, and they take limits h goes to 0. And the reason for this is, let's consider a point A here, which has an x coordinate x and a y coordinate f of x. And then let's consider a point B here that is located further away, which has, let's say the x coordinate is now x plus h, like it's been shifted over a little bit. And then the y coordinate would be f of x plus h. If you were to then try to figure out what the slope was between these 2 points, right, which is y2 minus y1 over x2 minus x1, that's the same thing as y2 minus y1 over x2 minus x1. And then x plus h minus x becomes h. And now, this is the same thing as the limit definition of a derivative. What you do is you take the limit as h, which is this separation between the 2 points. As that gets like closer and closer, it basically looks like the derivative, which is the tangent line. Okay, so you see like it gets closer and closer. So there you go. That's where it comes from. It's pretty cool. But yeah, go check out the video if you want to watch it again a couple times. All right, so let's see. What I like to do in these situations here is I'm going to write out what f of a is. So f of a, in this case, would be equal to 5. You know what? I don't really like... I think I'm going to write this in terms of exponents. I'm going to say 1 plus EA, right? And I'm going to say to the negative 1/2. And then f of a plus h is equal to 5 times 1 plus. And so now, instead of x, we're going to write a plus h to the negative 1/2. Okay. And that's over h. Cool. All right, so substituting in, right? This goes to this. This goes to this. We're going to get this minus this all over h. And then we're going to take the limit as h goes to 0. Okay, so the inherent problem here is that if I plug in h being equal to 0 right now, we have a little bit of a problem because we're going to divide by 0. And that's not allowed. So usually what the goal here is to do some sort of like algebraic voodoo magic here to like pull an h out so that I can finally cancel these. It's like what I want to do. How do I do that? I see. Actually, I think I do want to write these as fractions. I'm going to combine the fractions. That's what I'm going to do, right? I think that's what I'm going to do. Yeah. This is, in fact, not what you want to do? Oh, okay. News to me, bro. You want me to multiply by the conjugate, maybe? I can multiply by the conjugate. That would do some
I was
shit.
going to say, the conjugate's probably going to be easy since you have
You're
the
right. Yeah,
square
let's do it.
roots on the bottom. They'll cancel out, and you'll get a prettier expression.
Okay, so let's multiply by the conjugate. So I'm going to multiply by this plus this. Ooh, let's get it. Yeah. Yeah, and the reason why we're doing the conjugate, so this is going to be plus. Is because of difference of squares. So I'll show you what we mean by that. So here, I'm multiplying by 1 technically, right? Because I'm multiplying by thing over the thing and they're the same, right? But if I have, for instance, a minus b, and I multiply that by a plus b, that's going to get me a squared minus b squared, which is nice.
Good
Especially
job.
if these are square roots. So for instance, if you ever see like the square root of a minus the square root of b, multiply that by the square root of a plus the square root of b, and that will end up giving you a minus b, because it would be this thing squared, square root of a squared, minus this thing squared, which would just be a minus b. Do you need a minus 1/2? Sorry, yeah, sorry, this one should have been a minus 1/2, my bad. My bad. There should be a minus here. Yeah, you're right. Yeah, it's just a different way to write it. Yeah. The reason I'm going to do this is because now this thing together is going to be this thing squared minus this thing squared. So I'm going to get... It probably looks easier in fraction form. I like the exponents. So that's going to become... This is going to... And then we have to also square the 5. So this is going to become 25. And then this is going to be to the minus 1. Minus 25. And then this is going to be to the minus 1. Right? And then this is all over h times this still. Right? Okay. Bum, 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 bum. Oh, yeah. Well, here's the cool thing. Yeah. Okay. I see what I do here now. First of all, I can factor out a 5 from everything here. So that, there we go. Right. So then we have 5 over h, and then it's this to the minus 1 minus this to the minus 1. Okay. And then it's divided by this plus this. Move. Okay. I still want to get rid of this h somehow. Can you imagine a software that could assist you? Yes, I could. Yeah. I need to install your stuff, actually. Sorry. Yeah. Thank you again for sending me that link. Yeah, I have it. I'll install it for my Mac. I really do want... Yeah. Imagine, Mathematic Fanatic, if we had some sort of software that could visually show the algebra for this. Imagine. Alright. Okay. This is where it might look easier as fractions, because I think I need to combine these fractions. And then... once I do that, they will cancel out an h somehow. Okay, so let's write that. Let me just write that for you guys. So this is 1 over 1 plus e a plus h minus 1 over 1 plus ea. No, you're not sarcastic, dude. You're good. I do need to try your stuff out though. I've been like catching up with work and then also jet lag. Okay, I'm gonna leave this on the bottom though. I'm gonna leave it how it is here. Okay, to combine these fractions, I need to multiply this by 1 plus EA over 1 plus EA. And then I need to multiply this one by 1 plus EA plus H over 1 plus EA plus H. Yeah. This is just mean, right?
It might help with the algebra if you break it up into two fractions. Right?
Oh, if I do this over this and this over this,
each one of those 1 over terms will go into the exponent of one of the terms. See what I'm saying? Like the 1 over E times A plus H will go into.
Oh, I like that. I like that better actually.
Bottom,
yeah.
And then simplify out the
beautiful
irrational terms.
I see what you're saying. So you're saying I could write that as this fraction minus this fraction.
And then you can evaluate the limits for each fraction on their own, but it's
all right, let's do that.
Gonna simplify your rational terms a bit.
Okay, so 5 over H, and then so this is gonna be 1 over. Oh, this is so funny. I get it. Yeah, actually, okay, cool. I see what we're saying. Okay. 1. Thank God for copy paste. Divided by all this. This is just a pain in the ass. I don't know like what this teaches you, other than like I hate math.
Oh no.
Or not that I hate math. I hate your teacher. I'm not learning anything new here. I'm just learning what pain is. But whatever. Okay, so this is 5 over H. And that's all over this thing again. Yeah, I'm sure there's some murderous chain rule ones too. Okay. So then... Oh, a video game experience. That'd be fun. Okay. So this is going to go on the bottom, but then these things are already like on the bottom, right? So you end up having like 5 over H over, and then this is going to be, oh man, 1 plus E A plus H, right?
But see how it's the same thing in the parentheses, so you can just simplify the exponents there.
Simplify the exponents.
Yeah, because it's negative 1/2, and then that would be to the 1, so you just get to the 1/2, and then you would just multiply it to that other added term.
I see. Yeah, I see. Because this would be multiplied by this to the minus 1/2. Right. Okay. I got you. Right. And then this is plus 1 plus E A plus H. And then this is 1 plus EA to the minus 1/2. Okay. So here, because you have something to the first power being multiplied by something to the minus 1/2 power, that's going to be something to the half power. So I get 5 over H divided by... What's up, what's up, Beldam? Okay, this is to the 1/2, right? Plus, and then this is gonna be 1 plus E A plus H all over 1 plus EA to the 1/2, right? And then, let me see. If we take the limit as H goes to 0, I think we're still in trouble, though. Right? Because I'm still dividing by 0. Especially if this, like, comes down, right?
Yeah, but I think if you multiply the H into those exponents, I think you can get away with it.
I think I need to, like, No.
I'm not for
No.
it. Yeah.
Yeah, I needed to cancel. There's too many pluses here. Yeah.
Oh no.
Goddamn. I don't think we want to separate this because I think I need something to cancel here. The minus signs help us, I'm pretty sure. I think.
Yeah, it's definitely possible.
Yeah, let's try it.
This is a mean question, to be honest.
This is just super ugly, dude.
Oh no.
You're not that guy, pal. Trust me. You're not that guy.
Yeah, this is just mean. Your teacher's mean, dude. Jamarcus goes to like some super advanced, like, I remember Jamarcus was going to like Russian school for math classes when he was in middle school. Which is just like pain. But I guess it builds character or something. Okay. All right. Let's combine these fractions. And so you get 1 plus EA, right? Uh-huh. Okay. And then that's minus 1 plus A plus H. Yeah. I think this is what happens here. Watch. And then this is... Remember, this is 5 over H. And then this is over all this stuff. So watch what happens. Worst few months of my life. Those geometry questions, yeah, they were pretty bad.
Surprise, motherfucker.
Okay, watch what happens. 1 minus 1 EA minus EA, and then you're just left with minus EH on the top here. Sorry, this is 5 over H. This is the beauty. You want to keep the minus sign. Because now you're left with 5 over H. And then this is just going to be minus EH. It's just like and then over all this fucking hot garbage. Okay, cool. Okay, but here's the cool thing. Again, you want to try to this H, this was the problem child here. We wanted to get rid of that. And the way we did it is because now I have an H on the top, and this will cancel. Now all is right in the world. You have negative 5E over all this, which at this point I want to take the limit as H goes to 0 because I'm no longer dividing by 0. So this is going to go away. And then, so you get negative 5E. And then this is the same thing. Look, 1 plus EA to the minus 1/2. 1 plus EA to the minus 1/2. So that's 2. 1 plus EA to the minus 1/2. Which I think we can then write as negative 5/2 E square root of 1 plus EA. Or I guess you could bring the E in as well. You could say, nah, let's just leave it. I think this is okay. Is that what you got, Jamarcus? Is that it?
I think we messed up a sign or one of the exponentials somewhere. Because if you were to just do the derivative normally, it would go to a negative 3/2 sign.
Let me think. 1/2. You are right. There should be a 3 somewhere. Where'd the 3 come from? Yeah, because let's think about if you want to just do this regularly. Okay, so this would be 5, 1 plus EX to the minus 1/2. So if you take the derivative, you get negative 5/2. 1 plus EX to the minus 3/2. Got you. Okay. So we're close. Yeah, I need a 3/2. Oh, and then times E, right? Times the derivative of X, yeah.
Yeah.
Yeah. So we're good here. We're good here. This is what's wrong. This needed to go to minus 3/2, we think, somehow? How did that happen? Oh, you know what? Yeah, wait. I know what fucked up. Okay. This should have still been down on the bottom. That's why. Yeah.
Oh yeah.
Got you. That's where we messed up. Yeah. I got excited and just consolidated the numerator without also consolidating the denominator. Yeah. Okay, my bad. Another broken kidney question in the queue. Oh no. Okay, so yes. So I forgot about this, which was another 1 plus EA, 1 plus EA plus H. Right? Okay, cool. Put that in here. Just call it what it is. Cool. This goes away. So then you get this to the third. Because it's this. Yeah, one second. And then. Wait, and I think that was to the. Wait, one second.
Oh, I see. It's when we consolidate the numerator, it's should go to a 3/2 on the bottom.
Yes.
There.
Yeah, right here,
So
right?
It should be a positive. Yeah, it should become a positive 3/2 because you get 1 plus EA squared, and then that squared would turn the bottom into a 3/2.
Got you. Yeah, okay, this is 1 plus EA squared. Yes.
Oh, I didn't even see that plus H, but yeah.
No, you're good. No, I see it. Yeah. But when the H goes away here, so this is the same thing as 1 plus EA squared, and then squared in 1/2 gets you squared and minus 1/2 gets you positive 3/2, which is why we get this. Okay, cool. All right.
Yeah, but that should be on the bottom.
Should be on the bottom. Oh, yes.
Yeah. One over.
Yes. Sorry. Yeah. That's what I'm gonna say. Yeah. Yes. There we go. Okay. Now all is right in the world. Yes. This is square. Dude, keeping track of all the... Dude, this is a fucking mess, dude. This is such a mess of a question, dude. Okay, cool. But I think we did it. Congrats.
This is mean, really. Yeah, it is.
24 minutes that one took, Jamarcus. How long did you have on a test to do that? How long did you have? You think you did it in 8 minutes? Nice. Dope. I mean, we were kind of taking our time, but yeah, that's just mean, dude. It's so mean. All right, let's see. What else we got on the queue? Ooh, Lucky Cat. Are you gonna be lucky today, Lucky? 30 minutes total for 7 questions. I would hope the other 6 questions were nearly as bad. Okay, let's see what we get. Let's choose a winner.
Let's go gambling!
Oh no, it's broken kidney.
Oh no.
This is rigged, breasticles, dude. What? You're at 46%. Let's see. What's broken kidney's question?
Oh dang it!
Oh man. It's this and like Mr. Silver, dude. When Mr. Silver like gives me questions, yeah. All right. It's okay, Stormy Gaming. I may pass on this one quickly, just because sometimes these are really difficult, and if I don't have like Narosky or Zach or other high-level math people with me, I just can't do these. Fenbox says the answer is B. Okay, cool. Let's see. Maybe this is doable though. Okay. Let f be a set of functions 0 to 1 maps to r continuous on. Okay. So the function's cool from x equals 0 to 1. It's twice differentiable, which I think means the second derivative can't be 0, right? F of 0 is equal to f of 1, which is equal to 0, and f double prime of x is greater than or equal to negative 2. Determine the maximum value of the integral. Okay. So, oh, this is kind of cool. We're trying to maximize this, so we want to maximize 0 to 1 f of x dx. Is that what we're trying to do? F double prime can be 0. It just has to exist. Okay. F double prime of 0 is greater than or equal to negative 2. Okay, if f double prime is negative, then I know it's concave down, right? Or no, sorry. Wait, no, sorry. F double prime could be positive or negative. Oh, man. Ah! That messes with me. Sure. So that's one function that does work. I agree with that. Negative x squared plus x. Because f of 0, let's say this was f of x. F of 0 is equal to 0. F of 1 is equal to 0. Cool. And then the second derivative of that, right? Would be negative 2x plus 1. F double prime of x would be equal to negative 2. Not f. Oh, I see, maybe. Jeff thinks you can use the mean value theorem. It's a trick I use for competitions. Yeah, okay, so if something has to be greater than or equal to 2, greater than or equal to negative 2, you could think about that in terms of, again, like a quadratic, right? Are you saying, let's say, for instance, this is f double prime of x. We're going from 0 to 1. That we're gonna pretend that there's a point down here at negative 2. And then you're gonna say that it looks like a parabola, I guess, right? Fanbox says I just solved it graphically. Okay. My question is, like, how do you determine, like, what the function is? You know, technically a straight line would work as well.
When I looked at, I just put in GPT.
Yeah.
They said, let g of x be f of x plus x squared was your starting point, right? So, because then when you take your second derivative, you get g double prime of x equals f double prime of x plus 2 is greater than 0, which matches your restrictions for your f double prime of x.
Okay, so wait, you're saying, one second. You're saying let g of x equal x squared plus f of x?
Yes.
Okay. So then g double prime of x, right, yeah, is equal to 2 plus f double prime of x?
And then when you plug in your conditions that they gave for F0 and F1, you get that it's concave down.
All right, so F0 is equal to 1. Sorry, F of 0 is equal to 0. F of 1 was equal to 0. How does that help? How does that help with that?
Because all that's going to be greater than 0 the whole time.
Wait a minute.
Oh no, I just misread what they said. Ignore that.
Yeah, look at it like, wait, what?
Yeah, I was reading that.
Oh no.
I was like, wait, how does that make sense? But
It's okay. Let's think about this. I kind of do like this idea. So we said f double prime of x has to be greater than -2, right? But I also need the function to hit 0, 0, and 1, 0 and still get a lot of area. In order, because yeah, we're trying to maximize this. I see. 1 sec. If you try to find an integral from x squared plus x f double prime of x dx, it'll be -2 integral f of x dx. Well, f double prime of x just has to be greater than or equal to -2. So x squared plus x f of x is greater than or equal to I'm trying to understand what Velo is saying here. Let me see. Breskles, what did you send me here?
that was what chat gave me.
Convexity proof and maximum. Okay. Alright. G of x is equal to this. G double prime is f of x. Okay. Greater than or equal to 0. Because that's... G's convex. So our convex function, the graph lies below the chord joining the 2 points of the graph. Just y equals x. Ooh. I still don't think I understand this one either. My brain. A triangle with a base on the x-axis from 0, 0 to 1, 0, and a vertex very close to 0, 2 is the graph I'm thinking of. The graph of what, Fembox, though? Sorry. The graph of the second derivative? Graph of the first derivative? The graph of f. Oh. Okay, 1 sec. You're saying f a triangle, so 0, 0, 1, 0, and 0, 2. What does the triangle do, by the way? Sorry. What's the point of the triangle? I think this is a graph of f prime of x, Fem. Because here, f, you know, this right here is the same thing as y equals what? Negative 2x plus 2. So y prime would be equal to negative 2. Triangle is an area. I'm not necessarily getting that either. G of 0 is equal to 0. G of 1 is equal to 1. So for a convex function, the graph lies below the chord. Join the 2 points. Okay. It's just y equals x. We get that g of x is always less than or equal to x. Okay. Plus f of x which is equal to g of x minus x squared is always less than... okay. Integrating from 0 to 1. I kind of see this, Breasticles. I kind of see it.
Yeah, I get what they're saying. It's just some of the...
It's like, where the fuck did they come up with this, though, dude?
Yeah.
Like, what? Yeah. Deadland Boy says, like, what am I seeing?
Oh, no.
Yeah. Like, first of all, this first thing here where you're like, oh, just let g of x equal f of x plus x squared. Like, where the fuck did you pull that out from, dude? What?
I kind of see it with the whole, like, -2 for f double prime, but...
Yeah,
not
kind of.
entirely.
All right. Here, I'm just going to pass on this one. But, yeah. Answer's 1-6. There's a bunch of different ways to solve it. I'll put it in my Discord. If someone wants to write something up that makes sense to me, I would love to see it. Thank you. Always fun, Kidney. I'll post Breasticles' little chat link for this one. I kind of get it. Oh wait, I think I'm all screwed up. Sorry, Jeff. It's okay. There is nothing wrong with screwing up. That's how we get better at things. Yeah. Okay, let's see. Next on the queue. Wow, Storm Gaming with a 29.6% chance. Breasticles with 40.1%. Yeah, no, totally. Yeah, I was scared by that question too, honestly. But I think the cool thing, Deadland Boys, is to be okay with being scared. Because it's an opportunity for you to be not scared once you figure it out. I think too often, and this is something I was definitely guilty of in college, if I started seeing things that looked like they were beyond my comprehension, I would like shut down. And then I would just resort to whatever, like copying my friend's homework or something, which is not a good way to learn. Just don't do that. I think there's a lot of value in struggling, and if you keep staring at something long enough, you will eventually get it. Or sometimes like have another friend like help with what you're staring at. That'll help you out as well. So, totally cool. My question is a basic school level shit. We'll see. We'll see, Storm Gaming, if you get picked. All right, here. Let's choose a winner. This is all completely random. So I have to be scared. It's Mr. Wasp.
It's not random. It's rigged. I promise.
Well, okay. Someone sent me a fucking screenshot of Google.
Aw, dang it.
Okay, this doesn't count as a question. Mr. Wasp, why'd you send me a screenshot of Google, dude? You're very lucky here that none of your links here are kind of messed up. That would be hilarious. Okay, all right, we're just gonna delete that one. Okay. Let's choose another winner.
Let's go gambling!
Storm Gaming, it's you, baby! Presticles, you need to not, like, do anything that's involved with risk today. Nothing.
Yeah, I can tell. I was the first one to submit, too.
You were the first one to submit. It's kind of funny how luck works, you know?
Yeah, it is.
Sorry, you're here for the ride, though. I know. You enjoy it. Storm Gaming has been like, dude, my question's so easy. Can someone help me, please? I'm like, okay, Storm. No, don't be sorry. It's okay. Don't be sorry. Imagine searching Google on Google. Totally couldn't be me. Okay, here we go. Okay, you have 3x plus 2. I think that's 2y plus 1 is equal to 0. And then you have. Well, interesting. Are there two different points here, or are these the same thing? You have x minus 2y plus 3 is equal to 0. And you want to find the equation of the line passing through the point of intersection lines. Oh, okay. And... Oh, wait. Find the equation of the line passing through the point of intersections. The English here is a little off. And then does it also need to pass through -1, 0? Is that what we're doing, Storm? It is kind of like two problems. Like, so here the first question is like intersection, right? Let's figure out the intersection. Yes, exactly. So here's the intersection is the x and y coordinate that satisfies both of these equations. Right? Okay. So the cool thing with this, this is already set up kind of nicely. You can literally just do what's called like the elimination method. I'm just going to add this equation to this equation. So watch what happens. 3x plus x is 4x. 2y minus 2y is 0y. And then 1 plus 3 is 4. And then 0 plus 0 is 0. So that tells me right away, if I move this over, right? 4x equals -4. Tells me x is -1. Okay. And then I just plug that back in to solve for y. So I get -1 minus 2y plus 3 is equal to 0. Here, let me put that in a different color. Yeah, pretty cool, Storm, right? Yeah. Okay, let's plug it back in. So -1 minus 2y plus 3 is equal to 0. So -2y is equal to -4. So then y is equal to 2. Okay, so your intersection point is going to be -1, 2. You could also like check that, like put it in here, make sure that works. So that would be -3 plus 4. Well, wait, -2, yes. Wait. -3, -4. Y should be... Ooh, wait. Y equals... Sorry, wait. Did I do something wrong here? Oh, wait, yeah, sorry. -1 plus 3 is 2. Yeah, okay. And you know why? When I tried to plug that in, it didn't work out. So that's something you should always do to check, make sure you're not making errors. Yeah, there you go. Y is equal to -1. I think. Yeah. We'll get there. One sec. Ooh. Why can't I understand functions? It just feels so hard. If you want a really cool video, Tanmay, on functions, go to my YouTube. You're watching this YouTube channel. If you go to search here, type in like functions. I have a whole video on like what a function is. It's one of my most popular videos. Well, if I could find it today. Here. Simple way to understand what a function is in math. Yeah. Go watch this video. It's pretty cool. I talk about like functions as like microwaves. Like you put shit into the microwave and then some voodoo magic happens and then you get stuff out. And that's like x going into f of x. And then f of x is like the popcorn that comes out. So it's a cool video. Yeah, okay, so intersection points at -1, -1. And then this is cool. Yeah, there is no slope here, actually. Right? You could try graphing this if you wanted, right? So -1, 0 would be here. And then -1, -1 would be here. So yeah, this is an interesting case. Because this technically has infinite slope. So usually, you're right there, Storm Gaming. If I had these 2 points, I would find the slope between them. And then you could use point slope form or slope intercept form to figure out what the equation of the line would be. In this case, this is a vertical line. So finding the slope here doesn't work. You're gonna get like infinite. You're gonna get divided by 0. Point slope form doesn't work for this. So what you have to recognize is that this is a vertical line, right? It's not that there's no solution. There is the equation of a line, but a vertical line in this case would just be x is equal to -1. That's the equation of the line. But it's also not a function. Yeah, they just wanted the equation of the line, though. They didn't want the function. They just wanted the equation of the line. So, yeah. In this case, yeah, the answer is just x equals -1. Does that make sense, Storm Gaming? So if m was equal to 0, that would be a horizontal line. This would be m equals 0. Here, you can try, like, figuring out what the equation of the slope would be, right? So it's y minus y, right? So that'd be -1 minus 0 over x minus x. That's -1 minus -1. Well, uh-oh. That gets me -1 over 0, right? -1 minus minus is +1. -1 plus 1 is 0. This is undefined. It's like infinite. Or negative infinite. Doesn't really matter, so yeah, so the slope is, there is no real, like, there's no defined slope for this one. Tame says, what do you mean by a system? Yeah, this is called a system of equations because you have 2 equations. They also sometimes call this a simultaneous equations, I think is what I've heard. Because you need to figure out an x and a y coordinate that make this true, but also make this true. And the way to visualize it is like, you could have rewritten this as like the equation of a line. Right? We could have rewritten this as 2y is equal to -3x minus 1. Which is the same thing, right? As y is equal to -3/2 x minus 1/2. And then you could have rewritten this as the equation of a line, which would have been y is equal to x over 2 plus 3 over 2. And then with these 2 lines, right? This one's going to slope down kind of like this. This one's going to slope up. And then so there is a intersection point where these 2 lines hit each other. And that's the x and y coordinate that makes this true, but also makes this true. That's why it's called a system. Yeah. So yeah, so Storm Gaming, m is not equal to 0 here. M is technically undefined. You have to recognize that a vertical line, the equation of that is just x equals something. Cool. Good question, though. I liked how it was multi-part. You had to do a system, and then you had to do... And then they tried to trick you up there. Okay. Nice. Good question, Storm Gaming. And then what we do, Storm Gaming, is every time one of these questions gets solved... yeah, there is an answer. Yeah. The answer is x equals -1. That's the equation of line. The slope is undefined, though. There's no slope. But here in our Discord, I'll always put like the screenshot for like the work we did, so you can go back and watch it. And then also there's a link here on to the YouTube stream, and then like the exact time it happened, so you can always check that as well. Cool. All right, let's see if Breasticle's luck is gonna get better today. He has a 68% chance. Tanmay, nice.
Win, I'm assuming you vibe coded a shadow ban into your system.
The shadow ban, that'd be too funny, dude.
Yeah.
Well, you know what it is? It's actually kind of cool. All of these things are independent, right? Yeah. So, you know what would be fun, and I could think about coding this, to be like, what percent chance, like how unlucky was it for you to not get picked all these times? Like based on like your percentage was here, your percentage was here, your percentage was here. Like after every click, how what was the probability of this happening?
Pretty low, I think.
Yeah, right. Yeah, it would be cool to calculate that. Like with every spin, you get like a history to like what happened. Let me see what Tanmay submitted. Oh, this is cool, Tanmay. This is really fun. Oh, okay. That's why the answer is x plus 1 equals 0. Yes. Yes, exactly, Storm Gaming. Yeah, because do you see if you rearranged x plus 1 equal to 0, that would be the same thing as x is equal to minus 1. Yeah. Okay. Let's go spin the wheel. Choose a winner.
Let's go gambling!
Breasticles, your time has come. Finally, dude. It only took 92 minutes.
Only took 92, yeah.
Alright, let's see what you got for me. Ooh, fun. Are we gonna do some Feynman techniques for this?
That is one way that you can solve it, yeah. So that's
Okay.
there's two ways you can solve it. I'll show you both.
Show me both.
So my favorite uses the Laplace equation. It's kind
Ooh.
of like, it's a bit excessive for solving this, but I think it's cooler.
We like
so-
the Laplace.
Not the transform, the actual
Oh, we're not-
Laplace equation.
Oh, we're not going to transform. We're going to use the
it's
actual. Let me go look at what the Laplace equation is.
It's AXX plus AYY, or sorry, UXX plus UYY equals 0.
Oh, okay. Is that true just for everything? Or kind
Yeah,
of-
so technically, the way the Laplace equation works is it's a little bit different from like the wave equation and the heat equation, and it's based off your boundary data. So you can have a bunch of different equations based off of what your boundary data is. So like if your boundary is a square or a circle, it's a different answer. And sometimes you evaluate or solve the Laplace equation differently based off of what your boundary condition is.
Okay. So yeah, I'll agree. So yeah, second partial of u with respect to x, which yes, you can write as uxx. This is one way to write this. And then you can write this as the second partial of u with respect to y, uyy.
Yeah, this one gets kind of funky though, because we're not gonna use it x and y. We're gonna add in two parameters, a and b, and then so technically it's the Laplace equation, but it's with AA and BB.
Okay.
It's still like totally valid to do. It's just
Okay, we're gonna say AA and BB.
Mm-hmm.
Okay, cool.
And then so we're gonna place our A up in the e to the negative x, and then our B in the sine of x.
Okay. All right, so let's see. So I'm going to say this is now 0 to infinity. We're going to say e to the negative a. Negative ax maybe? Or what?
Yeah, negative ax.
Negative ax. And then I'm going to say sine of
Bx.
bx over bx?
Just x.
Just over x. Oh, okay.
Yeah, just over x.
And then this is still dx. Okay.
Mhm. And then what you'll notice is if you take your UAA, when you take that partial derivative,
Yeah.
it brings down an x squared, right? And your one of your x's cancels.
Okay, so
but
let's
it
see.
stays
So
the same.
are you also saying this is equal to u?
Yeah, technically.
Okay, so you're saying the whole integral here is equal to u. So UAA would be the second derivative of this with respect to a. Which, yes, okay, the d squared dA squared of e to the negative ax, that would be equal to, you pull down a negative x, and then you pull out another negative x, so it's x squared e to the negative ax. And then d squared db squared of sine bx. I don't care about the other x. That's going to give me negative x squared sine of bx, right?
Uh-huh.
Because derivative of sine is cosine, derivative of cosine is negative sine, and then each time I do, I have the chain rule, I pull out an x. Okay, cool. All right, so UAA is equal to the integral from 0 to infinity. Or actually, can I just leave this as, UAA is equal to x squared u?
You could, but it's a bit cleaner to get to what we're trying to, because we're trying to basically just show that this meets the requirements of the Laplace equation, right?
Okay.
It satisfies the Laplace equation.
All right, so I'll leave it like this. I'll say 0 to infinity e negative ax.
And your x squared should also be inside your integral, because your R integrals with terms to x.
Correct. You are correct. Sorry, the integral's in terms of x. Yeah, you're right. Oh, that's why I can't write it. It's just x squared u. Yeah, I got you. Okay. Storm Gaming says my teacher just put x equals 0 in point slope form. What?
You done messed up, AA Ron!
You can't do point slope form for vertical lines. I don't think you can.
Not that I know of.
Yeah, not that I know of. Yeah. Okay. All right, and then UBB is equal to 0 to infinity. All right, let me put these BBs a little bit lower. Negative x squared e to the negative ax sine bx over x dx. And is this true that this equals 0?
Yeah,
Yes.
because if you
Right?
bring
Because
out the
this and this are the
negative,
opposite.
right?
Yeah.
And they
Okay.
So now that we know that it solves our Laplace equation, we want to do it's basically checking if it's invariant to scaling.
Yo. Excuse me. What?
Right, invariant means that it doesn't change. So in this case, we would basically check that our u of AB, when we scale it, doesn't change based off of what we scale it by.
Okay. Check invariant under scaling. So I want to see if u of a comma b
Is equal to u of AB, but with a u of lambda A, lambda B.
Okay.
Which is just some scaling factor.
I see. Okay.
So then you would plug your lambda A and lambda B in, and then simplify. And so if you can get that
So this is u of
to
a.
work out to be UB or u of AB, we'll say it's invariant under scaling.
Okay. Discord. Yes, Discord link should work. If that Discord link doesn't work, Sir Spiderstop, if you go to the website, actualofficehours.com, and you click here on join our Discord, it should also work as well. That link should always work. Okay. All right. So then this is negative lambda A, and then this is lambda B. And I want to show that these are the same? How can these be the same?
So what you want to do is make a substitution and say y equals lambda x, right? Because right now x is just a dummy variable of integration, so we can just kind of substitute how we need to be. So you would say let y equal lambda x.
Okay, so then dy is equal to lambda dx, right? Is that what we said?
Yeah. And then dx is dy over lambda.
Got you. Okay, so now we're going to substitute... one second, let me move this around. Move. Okay, so this is now going to be y. This is going to be also y. Oh, cool. And now x is going to equal y over lambda. Right?
Mm-hmm.
But now... Oh, but dx is equal to dy over lambda.
Yep.
And lo and behold, these will cancel.
Mm-hmm.
And now we're back to the same thing, because y is just is a dummy variable.
Yeah, and
Okay.
so now that we've shown that it's invariant under scaling, this is kind of when the magic comes in. We know we have a partial differential equation, but because we know that it's invariant under scaling,
Okay.
we can reduce it to an ODE because it only depends on the ratio of B to A.
Okay.
So you would be able to then say our U of AB is just equal to a function phi of B over A.
Okay.
And then from there, you can substitute into the Laplace equation with our function phi. And then it gets down to a normal ODE that we can then solve.
Okay, so wait, let's see. Okay. So then am I gonna do this? Am I solving for a new UAA?
Check
Sorry.
my work and verify.
Yeah, let me see. Because I agree this is, again, the Laplace equation.
So, yeah, so we're saying our phi is, say, phi of t is what I wrote it as.
Phi of t, where t is b
so,
over a.
Yeah, so. Mm-hmm.
Okay.
And then you can compute your derivatives of TA and TB and your second derivatives.
Okay, so TA is going to be equal to negative b over a squared, right?
Mm-hmm.
And then TB is equal to just 1 over a. And then you want TAA? You want the second derivative? Sir Spidey says, how hard is AP Physics C mechanics? I mean, by the statistics, technically it's one of the hardest AP exams. I don't think it's that difficult. I've taught it a lot. We are going to be doing kind of like a boot camp for AP exams coming up in the next couple weeks. So, yes, good thing if you were looking for our Discord, join our Discord, and I will make an announcement about a little, like, fun study course we do. And then I also do a couple study review streams to get ready for the AP Physics C exam. But if you're thinking about just taking the class, yeah, I highly recommend it. It's one of the most useful classes besides chemistry for getting AP credit, at least for college. It'll help you out a lot. Okay. All right. What are we doing next here? Breast.
Okay. So, real quick, recognize that since our T is T over A, we can rewrite our TA as T over A.
Oh, okay, cool. Negative T over A, no?
Yeah, negative T over A.
Okay, and then I can write this as TV.
You could, but it's better if we just keep it as 1 over A for now.
Okay, we're gonna leave it. Cool.
So then we can figure out our UAA by taking our derivative of U of A with respect to our function phi. So you'd say that UA equals negative T over A phi of T, or phi prime of T.
Negative T over A phi prime of T.
Mm-hmm.
Okay.
Which is just by the chain rule.
The chain rule. Okay. Yes.
Yeah, because we say U of A, B,
Right.
take
Is
the partial derivative,
mhm.
and then
the derivative of t with
Plus
respect to
chain.
a is just negative ta.
Mhm.
Yeah. Okay.
And then so we can just take our another derivative with respect to A.
So UAA.
Mm-hmm.
And so that's going to be equal to ooh, is this a product rule now?
Yes, it is.
Okay. So that's going to be phi double prime of t t squared over a squared, right?
Mm-hmm. Yep.
And then that's going to be plus, because I'm going to get a minus from the other one. And I'm going to say t over a squared phi prime of t.
It should be a 2 in there. It should be 2t over a squared.
2t. Where's the 2 coming from? Wait, why is there a 2?
Honestly, I don't remember. I did this last night, and then
Where's the 2 come from? Storm
That's
Gaming,
where
join
the
the
two
VC.
in there
Yeah,
works out.
Storm, if you're in our Discord, just join the stage channel, and then when it's your question, I can bring you up to the stage to talk if you want. Okay, sorry. Where the fuck is that 2 coming from? Because it's with respect to A. Because derivative of this is phi double prime times the derivative of t, which we already, with respect to a, which you already said was negative t over a, so
yeah,
that's why that becomes t squared over
that
a
term's
squared.
definitely correct.
Correct. And then it's times the derivative of this with respect to a, so that should just bump the power to a squared on the bottom, right? And then it pulls a minus sign out, which would make this a plus, and then we leave this as this. Yeah, I don't know where the factor 2 comes from.
Oh, I see. I remember now. Because t is a function of b and a, so technically we have that t
is a
over
function
a.
Yeah.
Yeah, that t over a is technically a b over a squared. So we bring down that 2. That negative 2.
Oh, one sec. Oh, okay. I see. So you're rewriting.
Yeah, because we have to write or differentiate t as well, since it varies with a as well.
Oh, I see. What kind of question is this? This is above college. This is probably 3rd year college. Yeah, this is definitely not intro college. Storm Gaming says, what's the timer? The timer is how much time is left on the stream. What's up, Riper? Good to see you too. All right. I see. So actually, I feel like I don't want to leave t's in here at all. Right?
We can, because
I'm getting confused at all the different variables that are chilling.
yeah, the fractions kind of inevitably will cancel out, and we'll get ODE and just in terms of
Okay, so I'll leave this, but then okay, I see here when I do the derivative of t over a, which is the derivative of this. Now I'm cool with the 2.
Mhm.
I see. Okay, so wait. So I want TAA basically at this point, right? So TAA is 2b over a to the 3rd, right?
Yeah.
Which is the same thing as 2 t over a squared.
T over a squared, yeah.
Negative 2 t over a squared.
No, it should be a positive 2.
Yes, you're right. Actually, sorry, I'm looking at this one. Okay. All right, cool. I'm cool with the 2. Wait, but then this is a minus.
No, it'd be a positive.
No, you're right. Okay. Yeah, okay, cool. Okay. Okay.
And then we can do similar for UBB at this point.
Oh dear. Okay. All right. So UB is equal to phi prime of t all over a. Yeah.
Yep.
So then UBB is equal to phi double prime of t over a squared.
Yep.
Okay. Cool.
All right, and then from there we can substitute these into our Laplace equation.
Okay, so then, yes. So UAA plus UBB is equal to 0. So you get this whole thing here. Oh, 6 a.m.? Okay, peace. Yeah, make sure, join Discord. You'll get all the announcements, all the cool stuff we do. Okay, and then this plus this is equal to 0, right?
Mm-hmm.
Yeah.
Cool. And then we can multiply through by our a squareds.
Yes, and get rid of all the a squareds. Okay, cool. That goes away. Oh, so then I have, let's see, phi double prime of t, and then this is going to be t squared plus 1, plus phi prime of t, 2t, is equal to 0. Yeah?
Yep.
And then this is a ODE that we can solve.
Yeah, this one's pretty easy. We just do another substitution. We say let y of t equal phi prime of t.
Let y of t equal phi prime of t.
Yeah, and then we don't need to worry about any of the like y primes and stuff. It just becomes a double prime. So we just substitute that in. So we keep our 1 plus t squared times y prime of t.
Yep.
Plus our 2t y of t. And then this is a separable differential equation that we can solve.
2t y of t equal to 0. Okay, yes. Because this is ddt, I guess, yeah?
Yeah. So we can just move our t's to one side, our y's to the other, and then integrate.
Cool. All right, so let me think here. Sorry. So this problem seems more like a collaboration than normal. Yes, this is Breasticles kind of like walking me through like how to do this question. I'm actually kind of learning. It's fun. I haven't done much partial differential equations. All right, so I can separate this, sure, because I can put this over here, I guess.
Mm-hmm.
And then, let me think. Oh, okay. I can move this, and I can move this, I think. Yeah, okay, so.
Yeah.
2t dt over, so, minus 1 plus t squared is equal to dy over y. Integrate, right?
Yep.
So ln of y is equal to this is another u sub.
Yeah, but that one's an easy one. You just get 1 plus t squared.
Yeah, because the derivative of this does show up right there, which is nice.
Yeah.
Okay. Yeah, it's just 1 plus. Let me think. This is. Oh, it's ln of 1 plus t squared. No.
Yeah. Then. Yeah.
Negative ln. 1 plus t squared. Cool.
Mm-hmm.
So 1 plus. So sorry. E to the right.
We don't need to exponentiate, right? Because our y was our derivative, so we can just take another derivative.
All right, wait 1 sec. So y was equal to phi prime of t.
Mm-hmm.
So what do you mean? Sorry, take another derivative. You mean another integral?
Oh yeah. I guess we would exponentiate first.
Yeah, you have to exponentiate first, right? So e to the right. So that becomes 1 over 1 plus t squared. is equal to y, but then y is equal to phi prime of t. So then it's one more. Okay, so then phi is equal to arctan.
Yes. But with the C. There's a technically...
Plus C, yeah. Okay.
Well, the C would be a multiple. Because our C is going to pop up. At first, it would be C over 1 plus T squared. So it pops up when you solve that first ODE.
Oh, sorry. When we did this one, this was technically like plus C. C. So, yeah, whatever, C. Times C. Okay.
Alright. And then from there...
And then from there...
It's not too bad after this.
I gotta remember what the fuck was phi. Phi was U of AB.
Yeah, phi is still technically equal to our U. Because phi is... We're basically saying... If we have a function of these two parameters, because it doesn't change based off of what we scale it by, all that matters is like our ratio of our parameters.
Of A to B, yeah.
So we could rewrite it instead of saying like, two different parameters. We can just rewrite it as one parameter that's a ratio.
Okay. And the ratio is key. Okay.
And then from there, we can just say our phi prime of 0 is equal to 1. So 1 over A gives us C is equal to 1.
Okay. So C equals 1. Yes.
And then so we get our U of AB,
which is equal to phi.
Is equal to,
which is
equal to our arctangent of B over A.
Was it A over B or B over A?
B over A.
T was B over A. Yep. Cool.
And then from here, we can just plug in our specific values, which would be 1 and 1 in this case.
1 and 1. Sorry, where are we getting 1 and 1 from?
From our all the way up at the beginning, our original problem. We just want to know e to the negative x, sine of x.
Oh, fuck. Oh, that's so cool. Nice. AP Stats is great, Riper. I would definitely take AP Stats. It's a great class. Okay. I see. This is always so clever. Right, yeah, okay. Yeah, okay. And you say, for these to match... A equals B equals 1. So, U of 1 comma 1 is just equal to the arctangent of 1, which is equal to pi over 4.
Indeed it is.
And so that's the whole answer for this?
Yeah. And if you didn't want to go through all of that effort...
How did that take into account the bounds?
It did in us choosing our C value, because we evaluated it as a PDU, right?
I see.
So it just kind of works out.
Okay. This okay. I feel like this thing is a little bit of like some like voodoo magic, but that's where the bounds come from.
Well, it comes from when we select our B equals 0. If we were to say that B equals 0, the sign becomes 1, and then we would get a e to the negative ax, which we know that integral.
Got you. Okay. This is not calculus. Riper. This is not calculus. This is partial differential equations. This is like a 3rd year math course in college. There is a lot of calculus involved here. This is why it's important to know calculus. But calculus isn't that bad. I think calculus is one of the coolest classes to take. Okay, and is there like, okay, so we did it, yay.
And then if you wanted to do it like way easier,
yeah,
you could just do Feynman's technique, right? So you would choose your same A and B. And then you could, honestly, I don't think it even matters really if you choose to differentiate with respect to A or B.
Yeah.
It's definitely probably easier if you choose it with A, because the e to the negative ax never changes. But you could probably figure out both of them.
You just do D to the A. And so that pulls down
negative x.
Correct. Pulls down negative x. And then what? And then you do integration by parts?
Yeah, because the x is on the bottom cancel, and then it just becomes e to the negative ax sine of bx. You integrate it by parts.
Integrate it twice.
And then you could integrate your dUdA again with respect to
say IBB twice. And then question mark, profit. Yeah. Cool. Cool. Nice. Good question, Breskles. That was fun. Yeah, not so bad. I learned it. All these techniques are super cool, and then they just like work out at the end. Quite magic for sure.
It is.
Nice. Well, I think it was worth the 90-minute wait. At least for me, it was. Like,
that's worth it.
That was super cool.
Yeah,
less frustrating than other questions. Did you get the Steam gift card I sent you?
Yes, I did.
Nice. Sick. What are you gonna go get? What are you gonna go get with it? I always like to know what kids spend all their money on.
I've been looking through what the like sales they have on games.
The sales.
Are right now,
the sales.
Pretty good ones. It's either gonna be that or like a Rust item store. One of the two.
Yeah. Yeah, they talk about like nobody buys games on Steam for full price. They wait for them to go on sale.
Yeah, it's not worth it.
Yeah.
Especially now when it's like every Call of Duty game is like $60 and it's like 6 years old.
Try like 70, dude. 70 or 80 these days. Or more.
Yeah, they're scamming. You don't even get like a physical disc anymore.
Yeah. You will own nothing and you will be happy.
Pretty much.
All right, nice. Tanmay says, what is it trying to ask? Feels super abstract. Lol, again, I'm just in algebra. This was actually asking this was asking a thing. So this was asking you to evaluate an integral. So an integral, if you're in algebra, you probably haven't seen integrals yet, but integrals are asking if we were to graph this. I know this looks really scary, but you could graph it. If you were to graph this and then try to figure out, I think it would probably look something like this, wouldn't it, Breskles? Probably look like a decreasing sine wave.
No, it even looks just more like a decreasing exponential, because we have the negative e to the negative x.
Yeah,
is going to look a lot like exponential decay.
Yeah.
And then even the sine of x over x still looks a lot like an exponential decay. So,
I see. Yeah, so there's going to be like some slight wiggle. There'll be some slight wiggle, but you're not really going to see the wiggles.
There's a bit, but it's not noticeable.
But then what you're doing here, Tanmay, is you're finding the area underneath this curve is what you're doing. And this is a technique. So usually in calculus, you learn pretty easy. You work with pretty easy functions to find the area under. This is the case where the function you're trying to, or the graph you're trying to find the area under is really complex. And then this is like a complex technique for being able to figure it out. Yeah,
well, and part of what's nice about this technique is we know a lot about the Laplace equation and its solutions. So, for example, knowing that it satisfies the Laplace equation, we know that whatever solution we're going to get is going to be our harmonic function, which is a nice thing to know.
What's a harmonic function again? Sorry, you just like a trig thing.
We usually simplify it down to just it satisfies the Laplace equation. But it also satisfies, if I'm not mistaken, like your Cauchy-Riemann conditions in complex analysis. And so there's some other properties of harmonic functions. It also tells us things like that under conformal mapping, whatever solution we're going to get is still going to hold solving the Laplace equation. So there's different
there's a lot of cool high level math
things that
properties
we can figure out because this solves the Laplace equation. We can figure out a lot of other properties about our original integral expression.
Nice. Yeah, Riper's like, what am I hearing, dude? It's okay, don't worry. You'll get there. You'll get there eventually. Don't worry. You'll get there. All right, here. We got 47 minutes left. Let me see who else I can help out today. All right, let's go choose a winner.
Let's go gambling!
Lucky Cat, it's your day. Lucky Cat's lucky. Ooh, this is fun. This is probably more your speed, Tanmay. This is kind of like algebra, maybe pre-calc-ish. Pre-calc, maybe. Yeah, good exposure share. Yes, I 100% say to everyone who's watching, like, it's great for you to just, like, hear these words and see these things, because you will then recognize them later when you have to do things. Yeah, this is a function. Okay. Determine so determine a equation or / the equation. It's funny. That looks like this. Okay, so this is called a rational expression because it has like something on top, something on the bottom, like a ratio. With the following set of conditions: vertical asymptotes, horizontal asymptotes, y-intercepts. Beautiful. Okay. So vertical asymptotes occur. You do, yeah, you probably do, right, Reaper? Yeah, we do all sorts of math. That was a very the last question we did was a very, very advanced math question. This is kind of more like down to, you know, Earth level math. Okay, so vertical asymptotes usually occur when you divide by 0, which is bad. So, if the vertical asymptote is at x equals 2, I need... So, f of 2 needs to divide by 0. And what that means is, right, dividing by 0, that means that, like, cx minus d has to be equal to 0. Which, right, if it's f of 2, that means when x is 2, I need to divide by 0. So that tells me that 2c minus d has to be equal to 0. Cool? So that's one thing we know. Okay, cool. All right, horizontal asymptote at y equals 3. Okay, horizontal asymptote. Depends. There's the shortcuts for horizontal asymptotes. So you can either do the limit definition or the limit method to figure out what the horizontal asymptote is, or you can notice if something looks like this. Let me just copy it down. So if the power on the top is equal to the power on the bottom, right? They're both to the 1. Then the asymptote is at the ratio of the coefficients in front of those highest power things. So that's at y is equal to a divided by c. What's up, Video Games Wizard? Doing good, man. Hope you're doing well. So, and then they said the horizontal asymptote was at 3. So that means a over c is equal to 3. We got another equation. Cool. So here's one. Here's one. And yet, Jeff brought up a good point here. So we have 4 things we don't know. I don't know A, I don't know B, I don't know C, I don't know D. Scary, scary, scary. But there's hope. If you have 4 variables you don't know, you need at least 4 equations so you can figure out what they are. In this case, we've already come up with 2. So we need 2 more. Okay, another cool one here. Y-intercept at 0, comma, minus 2. Okay. So, y-intercept. Okay. That means that f of 0 has to be equal to negative 2. So when I plug in 0 to here, I need to get negative 2. So that means A times 0 minus B over C times 0 minus D must be equal to negative 2. Cancel, cancel. So I get B over D is equal to negative 2. And that's another equation. Cool. Okay. So let's try to like write out all the 3 things we know so far.
What's up, Shaq? Is this gonna be, no, this is not very hard to solve. Thank you, I do need some water. I need a hydrate today. Shaq's just buying all the stream rewards. Okay. Yes, if A, B, C, D works.
And multiples work by factoring, yeah. Okay. So I think we just have to get like one set of points that work, right? Because technically there are infinite solutions here, right? So technically, whatever, this works. But also if I just multiply this whole thing by 5, wouldn't that like also work? Right? Or sorry, on the denominator. Sorry, not on the numerator. Can't be the numerator. Yeah, sorry. Because, or wait, wait a minute. But it'd be both, yeah. Okay. All right, so let's rewrite this. So D is equal to 2C. A is equal to 3C, right? Rewrite from that. And then here we have B is equal to negative 2D. What's your best advice for feeling very frustrated and dumb if some concepts are scary, almost like anxiety? Yeah. Well, I think first recognize that's normal. People get anxiety and like scared from shit like all the time. It's totally okay. Yeah. I think normalizing that you're not alone and it isn't just you. You're not dumb. Like even the smartest of people get anxiety when they see things that are difficult and hard. But the way to get over that, especially when you see things in tests, is to build up your self-confidence that you know you can solve things. I think I know it sounds cliche, but if you believe in yourself, then like nothing's really super scary because you know it will pass and you'll be able to solve it. The way to do that is, especially for tests, is to do a lot of practice questions that are similar to things you're going to see on the test. So then when something comes up on the test, even if it's scary, you have the confidence that you know you can solve something similar to it, so you should be able to solve this one. That's how I would say, like, get over anxiety in tests. Test anxiety is because you don't believe you can do it. If you believed you could do it, you wouldn't have test anxiety. You'd be like, oh, fine, I'm fucking great.
My man.
Where can you find practice questions? These days, AI is like your best friend. There's a really cool thing, actually. If you guys ever check it out, it's called Notebook LM. Yeah, you guys have it so lucky. Back in my day, we used to have to, either ask the teacher to give us or release previous tests, or we'd have to ask people older than us, like, do you have a copy of your test? Like it's kind of low-key cheating. But nowadays, you guys have awesome tools, such as, like, Notebook LM. You can literally, this is from Google, you can drag in whatever. Like, I would drag in, like, a practice test, for instance, and then once you have it, so here, for instance, I did one of these at one point. This was the Florida geometry and someone was asking me about how to study for some, like, Florida state exam or something. And what I did is I just dropped in some practice tests from, like, from the state board, and then it will create a podcast. It can create a mind map. It can create a video. It can create a quiz. It can create all this shit just based on the materials you give it. So this is super cool. And there's another thing, actually. If you're studying for the SAT, Google Gemini specifically has free unlimited practice questions that are vetted by like the Princeton Review. Like they know these things. Sometimes it's kind of a shit show trying to determine like what practice questions would actually show up on the SAT, but they have like the official tests. They've built out such a good AI that it literally gives you unlimited practice questions. Yeah, Notebook LM is great. It's Google. I think it's free. If not, I don't know. I feel like one of the best investments you could make in your education is $20 a month to have access to whatever the paid version of these algorithms. The Google one's really good for learning, for sure. I wonder how much artificial intelligence is going to change things in the education and school sector. It already is. Yeah. Changing things a ton. My teacher said just read your math book. Yeah, your math book probably has good questions in it. But again, with the age of AI, right? You could take a picture of the questions in the back of your book. You could upload it to this Google Notebook LM, and you could say just generate unlimited practice questions for you. And it would just keep doing it. It's very cool. But yeah, AI is already changing a lot of education. I think it can empower things. I think, like most new technologies, you can use it the wrong way, and you know, students will sometimes use AI to just copy paste like answers of their homework. You're not really learning, and that's gonna bite you later. I tell people that. Yeah, I know people say, "Oh, but it's due like in 10 minutes. I just need the answers to get a good grade." I'm like, "Okay, cool." But unless you're actually gonna go back and learn it, I know people say like, "Oh, I'll just learn it over the summer," or you know, I'll when I have time I'll learn it. They never actually do that.
Oh shit, not good.
And then you don't actually learn. So sometimes you need the wake up call of like getting a bad grade because you didn't turn something in to like force you to learn it. Yeah. So. Yeah, I know. Trust me. I mean, I did the equivalent of it in college, where if we had like big assignments due, and I was swamped with a bunch of other things, or maybe I was irresponsible with my time, I was partying too much on the weekend. Yeah, homework was due. I would totally just copy my friend's homework and be like, "Yo, can I see yours?" And like just. But then I would never learn it. I would say I'd go back and learn it, and then I wouldn't. But then the test comes up, and then it's like, now you actually have to learn it because you can't copy the answers for a test. So, yeah, you're kind of just like swiping the credit card, just like taking out debt at that point. So don't do it. Don't do it. No. Use AI to learn. Don't use AI to cheat. Okay. Yeah, wait. I think there's like infinite solutions for this. Can't I just pick something for C and then we're good? I think we can, right? I can just say like, because these are 3 equations with 4 unknowns, so there has to be something called like a free variable. So there's a variable that I can just like vary as much as I want. So I can say like, let's let C equal to 1. That sounds dope, right? Okay. Then D equals 2. A equals 3. And then B equals, what was it, -4. So there you go. So this is a series of equations that work. Yes, dropping self-ego is so important. This math is advanced functions. It is, yeah. Yeah, the ego is so important. Yeah. Being okay with the fact that, like, you don't know everything will help you so much. And also being okay with not knowing things not necessarily meaning you're stupid. It just means you haven't learned it yet. And there's room. There's room to grow. Okay, so then this is x minus 2. So there you go. I feel like that's a...
Good job!
Let's see if that works, right? Is the vertical asymptote at x equals 2? Yep. Is there a horizontal asymptote at 3? Yep. And is there a y-intercept at -2? Yep. There you go. That's it. Is this just 10th grade math? I don't know. Ask Pineapple. Is this Pineapples? Yeah, Pineapple. What grade are you in? This 11th? Yeah, cool. Yeah. Also, like, learning happens at all sorts of ages and times and paces. So if you're in, like, you know, 12th grade and you're like, oh, we haven't done this yet, don't think you're behind. And if you're in, like, 9th grade and you're like, oh, I've already done this, cool. Doesn't necessarily mean you're super ahead. It just means people see things at different times. All right, pineapple. Everyone learns at their own pace. As long as you keep learning. That's the important thing. I learned stuff today. Breasticles taught me about, like, PDEs. That's pretty fun.
I did, in fact, do that.
That, you know, that's I'm a huge believer in, like, lifelong learning. I think it's what keeps you, like, sane in this world. I think once you stop learning, you start dying.
Oh no.
So, keep learning. When the student is ready, the teacher appears. Wow, that's very cool. I like that. That's a cool quote, actually. Well, I'm gonna steal that. And yeah, not everyone gets the same learning opportunities. 100%. Also, I mean, I remember even my advisor. His name was Tom Intrator. He's a really cool guy. In plasma physics. He worked at Los Alamos National Labs. Really, really prestigious. That's where they developed, like, the atom bomb. I don't know if you watched Oppenheimer, but it's all about that. He used to be a what's it called? Someone who, like, makes, like, clay shit. What's that called again? Like a potter? Pottery. Yeah, he used to be he used to do pottery. And then I think at, like, 29 or something, he's like, I'm gonna go back to school and start learning plasma physics. And then he did. And, you know, then he was working at a huge national laboratory doing, like, fusion experiments. Really cool. So
Good job.
you don't have to, like, always know what you're doing and always be on that path. You can sometimes take little side quests and, like, be like, oh, I'll try this out. And you're like, maybe I don't want to be a pottery person. Okay, no, I'm gonna go back to this. Yeah, pottery. Yeah, there are not. Yeah, I will agree. It's kind of a rare case to go from pottery to plasma physics, but it's possible. Myself, I kind of did the reverse. I went from plasma physics to being an education influencer, and doing this type of stuff. So, but the journey, everything you do along the journey helps you to get to where you are right now. So everything is important. Everything's an experience. Nothing's wasted. MAGA Seths confuse me. Imagine being named after the patron god of foreigners and desserts, but loving ice. I don't know what that means.
Oh no.
You're Seth, you're confusing me. Yes, now to dissect it. Okay, cool. All right, let's go. See who's the next question we're gonna work on today.
Let's go gambling!
What do we got? Tanmay, it's you. What do we got? Oh, nice. I actually really like this one. This is a fun one. Cool. All right, Tanmay, let's help you out. Oh, desserts. Deserts, not desserts. Oh, sorry. Yeah, I read that wrong. My bad. Who's the patron god of foreigners? What? What? Like I know, like, the patron saint of things. Like Saint Anthony is the patron saint of lost shit. If you ever, like, lose something, just be like, Tony, look around. Something's lost, it can't be found, and then you say what it is, and, like, I guarantee you, dude, he comes down and finds it for you. All right, let's do this. Find the length of each missing side. All right. There's some information kind of missing here, but I think we need to assume that this is a right angle. I know they didn't necessarily tell it. Am I Roman Catholic? Yeah, I mean, my name is Giovanni Rossi. I have, like, the most Italian John Smith name ever. I'm technically Roman Catholic. I don't really go to church anymore. My spiritual beliefs have, like, changed over the course of my life. But I still think church is cool. Like, I would go. It's fun to, like, have tradition and shit. I don't know. It's cool. Like, I definitely believe in, like, a higher power. There's something. I don't know if it's necessarily some dude named Jesus, but there's definitely something. All right, let's assume this is a right angle. And there should be 180 degrees of total angle. Correct. Okay. Oh, you think we want to use law of sines maybe for this? Like, are we going to assume there isn't Are we gonna assume there isn't a right angle? We could. We totally could. Wait, I think I need at least one angle though, no?
But do we really want to do that when we could just assume it's 90 and then use?
I'm getting on like Naroski's level. I'm getting on Naroski's level of like they didn't give it to us like technically. 1 sec. I feel like it's really hard. It's kind of hard for people out of the education system to keep learning in the structured manner they might be used to, since they can't keep taking college classes. Yeah. Well, luckily there's you can take a bunch of college stuff for free with like MIT has like free classes. I think Harvard has some.
MIT's is great. Yeah,
MIT's is great. OCW is what it is. Yeah, open courseware. The issue is the motivation. Yeah, if you don't have like the threat of a bad grade, you know.
Surprise, motherfucker.
You might not actually do things. I get it. Yeah, there is no angle given. Yeah, exactly. Okay. I'm gonna assume it's a 90, right? Can we assume it's 90? Can we just do that? Alright, if it's 90, then a squared plus b squared equals c squared. Yeah. So that means y squared plus y minus 7 squared is equal to y plus 7 squared. Pythagorean theorem.
Good job.
Correct. Okay. So this is y squared. We gotta remember how to expand this. This is gonna be plus y squared minus 14y plus 49. Definitely refresh your memory if you forget how to do that. It's a very useful thing. And then this is gonna be y squared plus 14y plus 49. You could do that too, Jeff. Yeah, that would be a cool trick. Yeah, you totally could.
Yeah, I was about to say perfect squares, and then you'll get some canceling.
Yeah, I mean this cancels too. Cancel. Okay, so then I get y squared, and then if I move that over, I get minus 28y is equal to 0. Yeah. Okay. So y minus 28 is equal to 0. So there's two solutions here. You could have y equal to 0.
Oh no.
Which doesn't make any sense. Yeah, you can't have a triangle with a side length of 0. Or you could have y is equal to 28. Alright, that's the other way for this to become 0. So, so what's that? 28, 21, 35. Which is, as Fembox said, this is a 3, 4, 5. Because this is 4 times 7. This is 3 times 7. This is technically 5 times 7. Okay. Cool. So, yeah, answer there's all the sides of there's the side lengths. Does that make sense there? Tamne, how we did that? Or you let me know. You said you tried to do this and you couldn't get it. Maybe look back at your work and let me know like what steps didn't really work out. That was quick. Yeah, well, let me know if you want me to slow down and explain some of the steps. I totally can.
Baby voice is back. Yes, y cannot be 0. Can't. No. Alright, nice. Alright, cool, Tammy. Great question. I like it, it was fun. So, Tammy, what happens is we're gonna take your question here, it's gonna go into our Discord. Into our, like, our homework help channel here. And then
what I do is I will drag in the screenshot so that you can see the solution. And then there's also a link here if you ever want to go back and watch the video for like the live recording. Also, if you join our Discord, oh, is this your question, Tamne? Is this you? Are you Raiper? Yeah, no? Oh, okay. Well, Tamne, if you want to like come in here and like claim your question, you get points in our server for asking questions. And then with the points, we buy you gift cards and stuff. So, another little reward structure we have. So, the same place you went to go submit your question here, There's a link to join our Discord. Yeah. So Tanmay, go if you want to get credit for that question. You're slightly offended by Storm Gaming's question? Really interesting. Okay, here we go. All right, we have 2 left. 2 questions left. 22 minutes. Let me see. Dream of Dawn says, I've always liked the idea of the truly sacred beyond any true understanding. Oh, interesting. That's kind of high level there. Category Theory Kappa. Then let me see. Sorry. Let me catch up on chat. From the very distant place I'm right now, high school level theoretical math and physics looks so interesting, but obviously very difficult to get to the point of actually fully understanding. Yeah. Totally. I can understand. The good news here, Raiper, is that you did this at one point in your life, probably. And so if you start studying it again, you'll be surprised how quick it comes back. It's not going to be like totally fresh. It's like not going to be like total blank slate. Like your neurons and pathways have made those connections at one point. You just have to wake them up. Oh, high level. Oh, sorry, my bad. I read that as high school. Yeah, no. And me as well. So when I first started streaming, which is probably like 5 years ago, my top end of math was definitely probably calculus that I thought I could really teach. I had taken complex analysis, I had taken DiffEq, I had taken linear algebra, but I didn't really remember it very well, and I wasn't comfortable teaching it. And over the years, getting those types of questions and having other awesome people in our community to like help out and like either like refresh my memory or like show me new techniques, I think I've gotten pretty confident where like I feel like I could do a lot of DiffEq, I could do a lot of linear algebra, I could do a lot of like complex analysis now. And even some of the crazier stuff like real analysis and like set theory, I'm starting to learn, and it's not being as scary. So you just got to keep exposing yourself to it. And as someone said earlier, yeah, you can't let your ego get in the way. Like, it's okay to just be confused. Being confused is totally cool. It's part of learning. Okay, let's go spin the wheel. Who's the next question we're going to do?
Let's go gambling!
Storm Gaming.
Good job.
Okay. I know Storm Gaming left, but we'll still do Storm Gaming's question because other people can learn from it. Yes. Dream of Dawn. No, you're good. The issue is I would need an angle, right? I need an angle for that to work. What are some math concepts that still amaze you? Like, what makes math fun for you specifically? Oh, good question. What makes math fun? I would say, like, yeah, the real analysis stuff, and some of the proofs. Like, every time I get a proof by induction question, I always am amazed at how it works out. And I'm also, like, kind of amazed that I still don't get it, like, fully. But, yeah, the proof stuff's really cool. I want to get more comfortable with doing real analysis. I think it would be cool. I bought a book. Zach recommended a book to me, and I bought the book. Yeah, discrete as well. Yeah. How to do continuous. Given any combination of 3 angles and sides, you know the full triangle? Yeah, you do, Dream of Dawn. The issue is that we also didn't know the sides of the triangles because it was equal to y. If I had numbers, we could. Yeah, but the issue there, Dream of Dawn, is that like A, B, and C were all variables. It's all in terms of y. Okay. Find the average median. Sorry, what's the average median? Wait, what?
Oh no.
The median and the average are 2 different things. Find the average median age. Dude, this hurts. This hurts me, dude. What's going on here? What's this question even asking? Okay, you're saying I assume they mean the median. Okay. Let's just say the median. Yes, I see.
They might mean like the median of each class, like each 40 to 50, 50 to 60, and then average it. Maybe.
I don't know. Yeah, I don't know how this works.
I don't know either.
I think what you do is you say like, you got to go like from here to here, right? I think that's how this works. It's kind of a weird question. Do you walk to work or carry your lunch? I work from home, so like, I don't walk to work. Okay. All right, so yeah, I think maybe the wording on this is weird, but what I would do is I'd be like, okay, cool, 3. All right, now there's 1 left, right? Okay, 8. So then you go back 6, and then now there are 5 left. So then this is it, right? The median age is from 60 to 70. You have no clue what the distribution is within that bin. Whenever I get questions like this and I think they're just like shittily written, I will just send them at AI, just to like double check that like I'm not stupid. Because I love to see what AI thinks. Yes, I saw Equity did. Yeah. Yeah. Yeah, so 60 to 70, that's what we said. Oh, fascinating. Oh, there's another formula for this? Holy shit, what? Where did this come from? Look at this. They say 64.1. Wow, what? Okay, I haven't seen this. I think this is like some sort of... This is like this is an interpolation type question, answer. I don't think you need to go this crazy, Storm Gaming, right? Wow. Yeah, they're assuming it's uniform. Yeah. I'll put this in here, though, if you want it for later. If you really want to, like, impress your teacher. Because, yeah, it is technically weighted more on the left than it is on the right. So it should be at the slightly lower end of the 60 to 70 group, which is why it's 64.1. You can't assume... Yeah. Yeah, I think you just have to. Yeah. Yeah. Right, okay. Right. This is the lower bound. Yeah. H is the width. The width is 10. And then this is like the percentage of like where in the box are you? Like, so there's 11 things in this box, right? When doing the median, you have to ask yourself, did I like occupy most of these and like some of these to get to the middle? Or did I occupy like most of these and then some of these to get to the middle? Because that tells you like what you do assume it's uniformly distributed, but you're like, what side of the 60 to 70? All right. Dreamy Don says, I'm still confused about the triangle question because y is solvable with no angles thanks to the properties of a triangle. Yeah, but I like Dreamadon not assuming it's a 90-degree angle. Dreamadon, if you want to like try working on this, it's in our Discord. I would love to see like maybe take a stab at it. I agree that you can come up with like law of cosines to get one equation, and then maybe law of sines would get you some more equations, because you technically have 4 unknowns, right? You have 3 angles and y, so you need 4 equations. So you could get 3 from law of sines, and then you could get your 4th maybe from law of cosines. I think it would work. I just think it would maybe be a pain in the ass.
Oh no!
Because then you're dealing with it. Because they're not linear equations, right? They're trig. They're trig equations. Yeah, I think it's possible. I just don't want to do it.
Oh no!
Anyways, okay, cool. I think this is the correct answer here for you, Storm Gaming. Nice. Yeah. It's not harder. Well, it's annoying for sure. Yeah, it's definitely annoying. I would say, yeah, it's 100% annoying, you know. Yeah, okay. Okay, let's see. What else? Okay, so Equity did redeem the me first thing. So if you watch on Twitch, which again, if you're watching us on a bunch of different channels, highly recommend watching us on Twitch. That's where like we have if you're on like a desktop, for instance, it's really nice because it's widescreen and stuff. But we also have like rewards you can acquire from like watching the stream for a while, and we let you redeem those for like you can skip the line or you can do other stuff. YouTube and TikTok doesn't have rewards yet for like watching. So when they do, maybe I'll start implementing that, but for now, yeah. Equity did redeem the me first. So let's do it. You didn't know that, Pineapple? Oh, yeah. YouTube has XP points, cool. But can you cash those XP points in for things? Like, can you buy things? That is cool, though. I do like the XP. Yeah, the fans is cool. Maybe I could do a thing where, yeah, I'd have to see, like, the nice thing about Twitch is their API and stuff makes it very easy for me to integrate it with OBS to, like, trigger things. I'd have to see if YouTube has API access for that. Oh, bye for real this time? Okay. Peace, Storm. Okay, alright, let's see. Let f of x equal to this. What are the values of x for which f of x is less than 0? Okay. Okay, so these are two logarithms which are subtracting each other, which means I can write them as a single log, right? Because I know the log of a minus the log of b is the same thing as the log of a over b. Okay, so this would end up being log base 3 of x squared plus x plus 2 over x plus 6. Great. Okay. Now, they want to know when this logarithm is negative. And here's the cool thing about logarithms being negative. Logarithms are negative when you're taking the log of something that's less than 1. So, for instance, log of 1 is equal to 0. Log of something greater than 1 is positive. Log of something less than 1 is negative. And then just don't do log of 0.
Oh, no.
So, in order for this whole thing to be negative, I need whatever's inside to be a fraction that's less than 1. So, this is really cool. So, in order for this to be less than 1, now I can write out this is now a new inequality, right? So, now I'm going to say, okay, cool. X squared plus x plus 2. This has to be less than the denominator, x plus 6, right? Or you could have written it this way, right? X plus 6 is less than 1, and then you can just move that over. Cool. Let's cancel some stuff. And then let's move that over. So I get that x squared is less than 4. So, so plus or minus 2 are like the critical points of things. Yeah, does it work if x plus 6 is negative? No. Well, we're going to put some restrictions on things, watch. Wait, I think I see what you're saying. You're saying that this could be negative and this could be negative? I see, okay. Yeah, no. There's two cases here. Fuck.
Yes.
Yeah. Fuck.
Oh, no.
Is negative than
it's less, sorry, the absolute value of this is less than 1. It's annoying. Okay, fine. No, you're right. Okay, you got to solve both. So I have to say x squared plus x plus 2 over x plus 6 is less than 1. Or x squared plus x plus 2 over x plus 6 is greater than negative 1. Is that what I have to say? I think that is. Yeah. In either case, because when I, let me think here. Yeah. I think this is it, right? This is it. Yeah, this is what has to happen. This is how we write our absolute value. Okay, cool. So I'm going to get two different inequalities I got to solve for. Actually... Oh, you can't log it. Exactly. You're actually totally right. Sorry. This is actually what I need. Sorry. It has to be less than 1, but greater than 0. That's what I meant to say. Okay. Cool. Okay. These are the two conditions. Yeah. Got it. We figured it out eventually. Okay, so if I move that over, I'm going to get that x squared plus x plus 2 has to be greater than 0. That's one of the conditions. And the other one is that x squared plus x plus 2 has to be less than x plus 6. Cool. Okay. Cancel. X squared has to be less than 4. So, this is where I feel like I get confused on this one. So if x squared is less than 4, then x has to be between -2 and 2, right? You can't multiply inequalities by a negative. Wait, again, what about x plus 6 being negative? I don't know what you mean by that, Jeff. I can't just like multiply this over. Yeah, I think you just check both.
I see what he's saying. Because if, say, we chose -7,
yeah,
and we multiplied that through.
Yeah, it would switch the sign of this. Sure.
Sign flips, but given our equation and our conditions, we don't need to worry about that because it won't be an issue.
I think we just check the critical points, and we're just gonna check to the left and the right of it and just see what the fuck happens. Right? I think so.
Yeah. In this case, it's not gonna like pop up with two cases.
Yeah, let's just do this. So -2, 2, right? And then we're just gonna see like what happens. So, in the case of and then it can't equal that. So let's pick 0. Right, 0's in between. What happens? So 0, 0. So you get 2/6. Is that good? Yep. That's cool. -6 is not allowed. So 0's okay. Too much thinking, brute force. Let's try 3. So if I try 3, I'm gonna get 9 plus 3, which is 12. I'm gonna get 14. 14 over 9 is bad. So that's no. Why is, because of this. Because x squared has to be less than 4. So x has to be between -2 and 2. So that's why I'm calling -2 a limit. Because, yeah, let's say we go to -3. If I go to -3... Why? Because x squared. What? I take the square root, right? Right? Like, -1 works, right? -1 squared is less than 4. But, like, -2.1 doesn't work. Because now that's bigger. So that's what the square does. Yeah, check 3. That doesn't work. Check -3. Oh, had to reload and got ads. Oh, it's okay. Thank you for supporting the channel. Alright, -3. So 9 minus 3 is 6. 6 plus 2 is 8. Then you get 8 over -3. 8 over -3 is not really good, right? I don't think this works. So I think your solutions are just between -2 and 2. Yeah. Yeah, that came from this one. Okay. So I think the answer is -2 to 2. Yeah? We could graph it too. We could go check it. I implore you to go do that. Okay. Let's check this one. So this is log of x squared plus 3x minus 5 over 7x plus 16. And now they want this to be greater than 0. So I need this to be positive. Very fascinating. Okay, so that just tells me x squared plus 3x minus 5 over 7x plus 16 has to be greater than 1. Now we're no longer dealing with like this lower bound at 0. It just has to be greater than 1. Don't you also have to find the zeros? You mean find these? Well, this will always be greater than 0. Equity. It can't be equal to 0? Yeah, but I feel like this is always greater than 0. Like, the determinant of this would be negative. Yeah, sorry, not the determinant, sorry, the discriminant. The discriminant's negative, yeah. Yeah. Oh, dang. What's up, J-Pot Lover? Sub. Thanks for sub, dude. You are right, Equity. Yes, I would need to check when this is equal to 0. But it's always greater than 0. That's why, yeah, this one doesn't really, like, show you any new information. But no, you're right. It's good to check that. This one, for instance, will have zeros. Yeah. So right away, we can go check that, right? X squared plus 3x minus 5 equal to 0. Like, when does that happen? So x equals negative 3 plus or minus square root 9 plus 20 all over 2. Okay. So that's ugly. So negative 3 plus or minus the square root of 29 over 2. Ouch.
Oh no.
That hurts me. Hurts. It hurts. Hurts. Okay, so these are not allowed. Not allowed. I don't know where they are. Like, what's the square root of 29? I guess it's like almost like 5-ish, right? Yeah. Okay. This is greater than 1. So I'm just going to say x squared plus 3x minus 5. Yeah, those would be critical points. Yeah, for sure. They may not even be in the region, though. Right? We may not even have to worry about them. Realistically, not scary. Correct. Crazy one. Okay. So then we get x squared minus 4x. Oh, they finally gave us a break here. Right? Because this is factorable. This is 3 negative 7. Right? I think that's right. Okay, so then we have some critical points. So we gotta go check negative 3. We're gonna go check 7. Thank you, Flask. 5.385 is square root of 29. So let me think about that. So negative 3 plus 5. Yeah. And then 7x plus 16 is also a critical point because the denominator changes. Correct. This one has so many fucking... Dude.
Oh, no.
This is just ugly. Okay, whatever. So, x is equal to, negative 16/7. Oh, man. So, negative 16/7. Negative 3. I just don't want to do this. It's just ugly. No, it needs all to be divided by 2. What? Okay. Negative 3 plus square root of 29 over 2. It's like 1.1. And then, what's it when it's minus? Also, this is a non-calc. Well... Yeah, you could pick other things, I guess, that work. You could estimate. I'm just doing it for the sake of time. Okay. So then you gotta go check all these fucking regions, dude. Damn.
Oh no.
I don't want to check them. I'm just gonna tell ChatGPT to do it. But yes, you could go check them. Calc is slang for calculator. Oh, there you go. You got an answer key for me? Yeah. So they check 7. I don't know what they're doing there. That's kind of weird. Wait, I don't need a new project. Sorry, what? Just need a new chat. Yeah, mine has more critical points. Probably because some of the ones... Let's see. Combine the logs. Yep. Solve the inequality. Yep. 7 and 3, right? And then this one. This already eliminates... Interesting. Okay. Oh, okay. I see why you can cancel out some of them. Yeah. I see. Because when we did this one, sorry, this was not equal to 0. Well, wait. How are they doing that? Sorry, what? Now check the log domain. Yeah, but what if the top is negative, though? Yeah, I can ask. We did need to use the zeros of the numerator to solve the inequality, but we did implicitly account for them through the domain restriction. Yes, see, these are the zeros. This tells us the quadratic is positive outside of its roots. Oh, okay. I think it's okay. I think I understand this. So this is a positive quadratic, right? Well, because it's a positive quadratic. It's x squared plus 3x minus 5, right? So x squared plus 3x minus 5 looks like this, right? And these are the roots. So you know that outside of the roots, you're going to be positive. Because it's concave up. So, yeah, in order for the top to be positive, it has to be outside those roots. We simplified to this. Yes, at this point, we still have to apply domain restrictions, including this. I see. So when this happens, these inside ones, you don't even care about them. Yeah. This one, you don't even care about. You don't even care about this stuff.
You done messed up, Aaron!
Well, you don't care about this one, I guess. Because it's already outside of it. What about the other one being outside, though? Uh-huh. Yeah, this one conflicts with this one. Okay. So it's invalid. And this satisfies all the conditions. I see. Yeah, you could check all the zeros, or you can be like kind of clever, like seeing which ones are positive and which ones are negative. Oh, they both work. That's fun though. Cool. It's annoying. It's an annoying question. I'll just say just graph it.
Well done!
Go graph it. Oh, I cleared Mr. B's. Damn it. I cleared the wrong one. One sec, sorry. Equities is the one we did. There we go. Dr. Gold, its yield protection is for smart people. I don't know what yield protection is. Sorry. What? Yield protection? Oh, is university? No, university. You don't have to be smart to go to university. You go to university to get smart. Why can't it be less than the last critical point? Bum 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 bum. Let me see. Yeah, where did we get that last one there? One sec. This has to, okay. Since the log is increasing, this has to be positive and this has to be positive, or they both have to be negative, right?
Yeah.
Yeah.
So on that far left side, when it's less than -3, it's gonna output a negative value, which is undefined in the logarithm, unless you go to the complex plane.
Yeah. Okay. I think I see. Yeah. So x is less than -3, or x is greater than 7. But when you're less than -3, this is positive and this is negative. So that's why that doesn't work. Is critical point just another for critical numbers? I'm always sorry. Critical point usually refers to in calculus, where a point where the derivative is 0. Critical number here for inequalities is just finding out where the inequality is equal to 0. What's up, Fanatic? Back from tutoring? What were you tutoring? Okay. Here, I'm also going to include this link here, if you want to like go through it, just kind of see what they're saying. Some cool stuff. All right, let's see. I'm technically out of time, but I wanted to do some of these questions. Where was Mr. B? Let me see if some of them are easy. Yeah, you're welcome, Equity. Did I give you a point? I did. Okay, cool. Simplifying radical. Oh, very cool. Some nice little high school math. All right, Mr. B, I'm going to do this one real quick for you. This is cool. This is called related rates. Spherical snowballs melting in a way such as the volume is decreasing. Okay, so volume, so dV dt is equal to -1. And then this is centimeters cubed per minute. At what rate is the radius decreasing when the radius is that? Okay, this is cool. So this is called related rates. So we have one rate that we're given, which was the rate of the volume, and we're looking for the rate of the radius. So dr dt. So then what I always like to say is, like, here's our rate variables, v and r. So I need an equation that relates the two of them. And an equation that relates the two of them is volume is equal to 4/3 pi r cubed. Right? Sometimes this will be in terms of, like, another variable. So if it was like surface area, there'd be like a height on it. Okay, good to see you, Breskos. Thanks for being here. Thanks for teaching me some PDEs. That was cool. So sometimes, especially like if you have like the cone question, they're gonna ask like, what's the rate the height is decreasing when, I don't know, like the volume's like whatever. And in that case, you have to use like v is equal to 1/3 pi r squared h. And then this is something where you have two variables and you have to end up rewriting one variable in terms of the other one. You use like some triangle inequalities. Yes, this assumes it's perfectly spherical. Okay, so once you're done here, once you have your equation that relates the rates v and r, right? V and r, you just take the derivative of both sides implicitly. So this is going to be dv dt is equal to 4 pi r squared dr dt. And so what I did here is, right, the derivative of v is just 1, but then because I took the derivative of v, it's dv dt. The derivative of something r cubed is you bring the 3 out in front, that cancels. Right? and then that would become r squared. But then you need to write drdt afterwards. And then now you plug some stuff in. So dvdt is -1 equal to 4 pi. Ooh, what's the radius? The radius was 5, so put a 5 in there. And then drdt, well, that's what you're looking for. Okay. So you just move this over. And so you get -1 over 100 pi, because 5 squared is 25, is equal to drdt. And you're done. And then, yeah, technically this is centimeters per, I want to say, centimeters per minute. You could say it's decreasing at +1 over 100 pi, or you could say drdt is -1 over 100 pi. Both of those work. Okay, B. I like related rates. Related rates are cool. Mr. B. All right, let's see. I thought we did equities. We did equities, do we not? Oh, I have to delete equities. That's what I have to do. Has TikTok ever told you they have a program with your link? I heard links in live were punished. If I post the link in the chat, yes, they get mad at me. But I think if it's a picture, they don't get mad. So they haven't got mad at me with the picture yet. And honestly, like, you know, the other thing I could say if they really get mad is that if you go to the link in bio, the link in the bio of this page, that link is there as well. So that works. Do we stream tomorrow? Yeah, we are streaming tomorrow. So again, if you ever want to figure out when we're streaming, actualofficehours.com, click here, streaming schedule. You'll see the schedule. We are going to stream tomorrow. We'll be on tomorrow. I'm pretty over time, but let me just see. Calc homework, Raiper. I think I can solve both of these. Here, we'll do them. I'll do them. I'm feeling generous today.
Let's go gambling!
Nice, Alistair. I don't know if I know how to do that other one. That other one looks crazy. This one, this is a Gaussian. This is just a Gaussian integral. These are not nice. Yeah. Okay. Yeah. I don't think this is not an AP calculus question. They're not going to ask you to do the integral of e to the negative x squared. Yeah, this is the normal distribution. Yeah. I think you just look these up. No. How else are you supposed to solve these? Yeah, you should know what the answers to them are. I don't think you need to know how to do them, Alistair. Yeah, there's no way to express it. Yeah, this ends up being like something like really fucked. You should know what this is. Yeah, no closed form unless you count ERF, yeah. And yeah, I think the other one was I think it was -2 to the x, right? Is that what it was? Yeah. Yeah, yeah, look at the big warning signs here, dude. Yeah, you can't do these by hand. Yeah, these are special functions. All good. Here, I'll copy the link for it. I think your teacher wants you to know them, not know how to do them. You can't do them. Definitely not an AP calculus. Also, I don't know like why you'd actually need to know them. I've never seen this on AP Calc. My bad, Geo. You're welcome. It's okay. All right. That being said, we got one more question left. Raiper, it's gonna be you. We're still gonna spin the wheel though.
Let's go gambling!
What's the chance that he does get selected? That's how we know it's really rigged. It's you, Raiper. Let's see what you got. Ooh, this is fun. Why is it not copying? I need you to copy. There we go. Surprise, surprise. Okay. Square root of x plus 5 is equal to 2 minus the square root of x plus x minus 4. Is this solvable? This is kind of a mess. Because I would, like, usually I want, like, square, but, like, how what's the strategy when there's something else here? Multiplying by the conjugate isn't going to help me either, right? Or maybe there's just, like, guess and check, I guess. Actually, yeah, okay, so there are some requirements here. Yeah, right. Yeah. Okay, so there are some restrictions. Right? X minus 4 has to be greater than 0. X plus 5 has to be greater than 0. So you have x is greater than 4. Or x is less than... Or sorry, no. X is greater than 4, or x is greater than negative 5. X is greater than 4. Square root of x plus 5 is equal to the square root of 9. Oh. Wait. Are you're just checking if x is equal to 4? Sorry, less or equal to 4. Yeah, okay. Oh, I see. So you could actually just, like, plug that in, right? But that gets you 3. Is 3 equal to 2? No. And then negative 5. Yeah, it's not going to work. Oh. I'm showing the smallest value of the sum of the square roots is 3. Yeah. Oh. I see what you're saying. X plus 5 plus the square root of x minus 4. Yeah. Equal to 2. Okay, very cool, actually. Okay. So, wait. Yeah. This is actually not solvable. This is cool. Very cool. Jeff brought up a great point here. Yeah. So, by checking that, you can't take the square root of a negative number, so we're going to set the insides greater than or equal to 0. I get these two conditions that have to be true. This is like the superior condition, because if something is greater than or equal to 4, it's already greater than or equal to negative 5. So x has to be greater than or equal to 4. So if I rearrange this, and let's say we just plug in 4, you're going to get the square root of 9 plus 0 is equal to 2. This is 3.
Oh no.
3 is equal to 2. That doesn't work, right? And x is only going to get bigger. So this is only going to get bigger. It'll never equal 2. So, no solution. Nice question, Raikur. That's cool.
Well done.
No real solution, I should say. Yes, we're not including complex numbers. Nice, and you get a point for that, Raikur. Good question. All right, that being said, let's close out the stream. Thank you, everyone, for coming to Actual Education Office Hours. Appreciate all the questions people asked today. You guys are awesome. I appreciated learning with you guys. Our next stream is going to be tomorrow. So come on by. Come help you out. You can always check the streaming schedule. You can join our Discord. And then if you're not watching us on Twitch, you really should, because we're going to go raid somebody. YouTube doesn't have, like, rating yet, or even Twitch doesn't. Yeah. Yeah, you're right. Welcome, Flask. It's cool. All right, let's go raid someone. Who are we going to go say hi to? Who's streaming on a Monday? Who do I want to see? Today's Sunday. I'm like, who's streaming on a Sunday? Oh, Gartic Phone. I remember playing Gartic Phone. That was fun. They were playing games. This is someone doing. What's science doing? Here, banana genetics, monkey science. That's fun. Let's go say hi to science. Science is great. Okay. Enjoy the rest of your weekend. We will be back tomorrow.
Good job.
Peace.